Yes. Yes. Cek, 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 tes, dicoba. Cek, 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 tes, dicoba.
Mau santuy atau nyambel pedesnya yang Indonesia.
Cek, 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 tes, dicoba, tes, dicoba.
Mau santuy atau nyambel pedesnya Indonesia.
Cek, tes, dicoba.
Tes 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 tes. Tes 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 tes.
Tes tes tes. Halo guys.
Tes tes tes. Ya.
Pakai speaker. Tinggal. Boleh orang persetanya. Mereka live Zoom seminar. Hah? Sekarang lah mendaftar. Masuknya data dulu, nah, masukkan data nama dulu, nanti dapat sertifikat. Berapa? Kan dapat sertifikat. Masuk, masuk. Namun sama gitu aja. Di sini ada, tapi nampak banyak orang luar. Nih orang kita tidak ada nih Pak Taufik hasilnya. Hah? Oh, ya. Hah? Masukkan yang dikirim tuh. Ini nih ya. Ya. Tapi situ udah langsung masuk deh. Di kliknya itu udah langsung. Nah, link itu klik. Nah, ini. Zoom kan? Jadi. Nah, ini. Tapi ini Zoom ada nggak? Ini udah langsung ya tuh. Apa tuh? Open Zoom, tidak Zoom. Berarti Zoom yang install. Install dari Play Store lah. Zoom meeting. Jangan enak. Belum mulai ini? Belum? Biasa lah, yang gini-gini nih. Iyalah. Dari sini kan karena dikasih passcode ya, jadi kita Zoom. Sana pun kalau ramai kan tidak gampang. Sini aja. Sana sih jangan. Dia barusan. Berbicara. Ya. Nanti Udah banyak tuh dari telurnya. Oh, banyak di sana. Ya, ya. Masalah ini orang luar ini karena dia online ya. Entas lah. Direktif banyak di sana lah. Satria boleh gabung.
Cek. Satu.
Baru nak mulai. Tes itu. Baru nak mulai. Hah? Senang ngawak ya? Nah, itu masuk. Nanti kan ada rekamannya. Hah? Apa? Mute. Mana ada bed ini?
Cek. Dear ladies and gentlemen, before we begin, I'd like to take a few moments to explain the rules for today's seminar. First, please ensure your cell phones are on silent mode or switched off, so we don't disturb the speakers and other attendees. Second, we encourage you all to participate in the discussion session and ask questions related to the seminar topic during Q&A session. Please make sure your question brief and to the point to allow for productive session. And third, we request our attendees to refrain from any side conversation during the seminar, as it can be distracting for the other participant. Fourth, please make sure you stay for the duration of the seminar, as it will provide a holistic understanding of the topic. And we hope the participant will adhere to these rules and participate fully in this seminar. Thank you for your cooperation. Good morning, ladies and gentlemen. Welcome to the International Seminar of Smart Education in the Digital Era, integrating IoT and AI for enhanced learning experiences, organized by Electrical Engineering Department at Accounting Hall, State Politeknik of Pontianak, West Kalimantan. Assalamualaikum warahmatullahi wabarakatuh. Honorable the Director, State Politeknik of Pontianak, Dr. Haji Widodo, PSSTMT, Deputy Director for Academic Affairs and Planning, Haji Irawan Soeharto, STMT, Deputy Director for Finance and General Affairs, Ms. Linda Suherna, SAMSE, Deputy Director for Cooperation, Topan Prihantoro, STMT, and Senate Chairman, Professor Dr. Insinyur Haji Nurmala, MM, and Honorable Head of Electrical Engineering, Mr. Hasan, STMT. Head of Department Civil Engineering, Insinyur Hajah Eti Rabihati, MT. Head of Business Administration Department, Haji Meizi Fahrizal, SAMSE. Head of Mechanical Engineering Department, Masyari, STMN. Head of the Accounting Department, Dr. Riani SAMSI. Head of the Department of Marine Affairs and Fisheries, Mr. Jumadi Sudarso, SST, PEMSE. Head of the Center for Quality Assurance and Learning Development, Mr. Wendy Yuniarto, STMT. And Head of the Center for Research and Community Service, Dr. Belvi Patria, APIMSE. And distinguished keynote speaker from Unimas Malaysia, Engineer Dr. Yanuar Zulardian Shah Arif. And distinguished keynote speaker from the Montfort University, Leicester, United Kingdom, Dr. Seng Chang. And distinguished keynote speaker from University of Lille, IUT of Lille, French, Professor Dr. Ing Kamel Haddadi. Distinguished keynote speaker from TU Dresden, Germany, Professor Dr. Thomas Kochler. And distinguished keynote speaker from Politeknik Negeri Pontianak, Indonesia, Mrs. Mariana Shamsuddin, PhD, and all distinguished guests delegated. Honorable guests, ladies and gentlemen, by reciting Bismillahirrahmanirrahim together, the opening ceremony of the International Seminar on Smart Education in the Digital Era, integrating IoT and AI for enhanced learning experiences, today, 31st October 2024, officially begins. Bismillahirrahmanirrahim. To start this session, we would like to invite everyone to stand up and sing the Indonesian national anthem, Indonesia Raya. To the attendee are requested to stand up. Dear ladies and gentlemen, please take your seat. And as our welcome greetings, we would like to present to you a traditional dance. Give them a round of applause. Tari Sirih is a welcoming dance performed for distinguished guests. This dance is inspired by movements that symbolize greeting and hosting with courtesy and warmth. Tari Sirih is performed by 4 Malay girls and enjoy the performance.
Makan sirih tepak Melayu, lambanglah ada pusaka Melayu.
Soalnya saya di handphone nggak.
Tanah sirih ujunglah ujungan. Sirih di mata, hai beserta sana. Ujungan, aduhai sayang. Sirih dimakan, hai beserta sadar. Selamatlah datang, hai kami ucapkan. Aduhai sayang. Selamatlah datang, hai kami ucapkan, hai makan sirih. Kepada Tuhan, di pulau budiman. Makan sirih mengundur diri, salah dan silap maaf diberi. Makanlah sirih Tuhan budiman. Makanlah sirih Tuhan budiman. Sirih dimakan budiman. Sirih dimakan budiman. Makanlah sirih adat Melayu. Makanlah sirih. Makanlah sirih Tuhan budiman. Makanlah sirih Tuhan budiman. Sirih dimakan.
Thank you. And for the sake of running this event smoothly, we would like to invite you to have reciting praying together. To Mr. Yusril Eka Mahendra MT, the floor is yours. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi rabbil alamin, hamdan syakirin, hamdan naimin, hamdan yuafi ni'ma yukafil mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karimi wa azimi sultanik. Allahumma salli wa sallim ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Ya Allah, most gracious and most merciful, with humility we ask that you continually bless this international seminar. Make these events a means for us to broaden our insight and knowledge in the field of education, which is rapidly advancing in this digital era. Ya Allah, grant ease to our speakers as they share their knowledge and experiences related to integration of the Internet of Things and artificial intelligence to enhance the learning experience. Likewise, make it easy for us, the participant, to understand and apply the knowledge we receive. May these seminars enable us to contribute greater benefits to the world of education and society, especially in supporting technological advancement that bring progress to the field of learning. Ya Allah, keep us away from all obstacles, problems, and hindrances that may disrupt the smooth running of this event. May you always bestow your grace, protection, and blessings upon all the organizers, participants, and everyone who contribute to this event. Rabbana taqabbal minna innaka antas samiul alim wa tub alaina innaka antat tawwabur rahim. Subhana rabbika rabbil izzati amma yasifun wa salamun ala mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Amen. And distinguished guests, ladies and gentlemen, the next agenda would be the report from International Seminar Committee Chairperson to Ms. Sarah Bibi, SST MPD. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. As esteemed Director of Politeknik Negeri Pontianak, Bapak Dr. Haji Widodo ST, PSSTMT, who in this occasion is represented by Vice Director Bapak Haji Irawan Suwarto STMT, Vice Director of Politeknik Negeri Pontianak, Ibu Linda Suherma SEMSI, Bapak Dede Irwan STMT, and Bapak Topan Prihantro STMT. Head of Department of Electrical Engineering, Bapak Hasan STMT. Heads of Departments and Study Programs and Units in Politeknik Negeri Pontianak. Honorable keynote speakers and all online and offline participation. On behalf of the organizing committee, this is with pleasure and honor that I welcome you all to International Seminar on Smart Education in Digital Era, Integrating IoT and AI for Enhanced Learning Experience. This momentum's event mark a significant milestone for the Department of Electrical Engineering at Politeknik Negeri Pontianak. We have been planning this seminar since last years, and now, today, we are excited to witness its realization. The overwhelming response from participants with 60 online attendees and 50 online attendees from many polytechnic and universities across Indonesia. It is a proof to growing interest in smart education, Internet of Things, and also artificial intelligence. We are truly fortunate to have honorable lineup of keynote speakers from 5 different countries who are kindly willing to share their knowledge, their expertise, and insight will enrich our understanding of latest trend in Internet of Things and AI application for education. I would like to extend sincere gratitude to Politeknik Negeri Pontianak for the support. Finally, I would like to acknowledge the efforts of 16-member organizing committee. Their dedicated and hard works have been instrumental in bringing this event to success. Thank you all once again for your participation. We hope this seminar will foster meaningful discussion, inspire idea, and contribute to smart education, Internet of Things, and also artificial intelligence. And before I conclude my remarks, I would like to say one pantun to all of you. Jalan-jalan ke pasar Flamboyan. Lihat buah, ada rambut. Selamat datang hadirin sekalian. Awak datang, kami sambut. Wabillahi taufik walhidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Ms. Sarah Bibi. It's nice pantun, by the way. I thought it would be like walking or something. Okay, and the next agenda is a welcoming speech from the head of the Electrical Engineering Department, Mr. Hassan STMT, and the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Jadi enggak pakai pantun Pak ya. Yang terhormat Direktur Politeknik Negeri Pontianak, dalam hal ini diwakili oleh Wakil Direktur Bidang Akademik dan Perencanaan, Bapak Haji Irawan Soeharto. Yang kami hormati para Wakil Direktur, yang kami hormati Ibu Prof. Nurmala dan Prof. Ardi, yang kami hormati para ketua jurusan, hadirin sekalian, rekan-rekan dan tamu yang kami hormati, baik yang hadir langsung maupun yang daring. Merupakan suatu kehormatan besar untuk berdiri di depan Bapak Ibu hari ini sebagai ketua jurusan Teknik Elektro. Ini mencerminkan komitmen kita bersama untuk memajukan bidang teknik elektro dan mendorong inovasi yang mendorong masyarakat kita ke depan. Seperti diketahui, seminar ini dari 5 pemateri 5 negara yang terdiri dari Insinyur TS Dr. Yanuar Yulardiansah Arif dari University Malaysia, Dr. Seng Chong dari The Montfort University Leicester, Inggris, Profesor Dr. Thomas Kohler dari TU Dresden, Jerman, Profesor Dr. Kamil Haddadi dari Universitas Lille, Prancis, dan Ibu Mariana Samsudin, PhD dari Politeknik Negeri Pontianak, yang siap membantu kita semua dalam ilmu keteknikan yang sesuai dengan kebutuhan dunia. Kita berkumpul di forum ini, kita menemukan diri kita di momen penting dalam teknologi, evolusi cepat dalam teknik elektro, telah membuka berbagai peluang, mulai dari solusi energi terbarukan hingga teknologi jaringan pintar dan seterusnya. Diskusi kita hari ini tidak hanya menyoroti kemajuan terbaru, tetapi juga menantang kita untuk berpikir kritis tentang implikasi dari pekerjaan kita. Saya pribadi sangat antusias dengan beragam topik yang akan dipresentasikan, dari penelitian mutakhir dalam sistem tenaga hingga integrasi kecerdasan buatan dan desain elektro. Kita memiliki kesempatan unik untuk berbagi pengetahuan dan mengeksplorasi ide-ide baru. Saya mendorong Anda semua untuk terlibat aktif, mengajukan pertanyaan dan berbagi wawasan. Kolaborasi adalah kunci dari untuk inovasi, dan bersama-sama kita dapat mendorong batasan apa yang mungkin terjadi. Selain itu, kita juga harus mempertimbangkan dimensi etis dari kemajuan kita. Sebagai akademisi, kita memiliki tanggung jawab untuk memastikan bahwa ilmu pendidikan dan teknologi berkelanjutan, adil, dan bermanfaat bagi masyarakat secara keseluruhan. Seminar ini bukan hanya tentang pencapaian teknis, ini juga tentang membangun dialog tentang bagaimana kita dapat membentuk masa depan secara bertanggung jawab. Terima kasih kepada panitia penyelenggara dan relawan atas kerja keras mereka dalam mewujudkan acara ini. Dedikasi dan semangat Anda adalah yang membuat pertemuan seperti ini dapat terlaksana. Sebagai penutup, saya mendorong Anda semua untuk memanfaatkan seminar ini sebaik-baiknya. Mari kita berbagi pengetahuan, saling menantang dan menginspirasi generasi muda yang akan datang. Bersama-sama kita dapat menerangi jalan menuju masa depan yang lebih cerdas dan berkelanjutan. Terima kasih. Semoga diskusi ini serta kolaborasi ini berlanjut ke depan. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hasan, STMT. And it's time for us to listen the speech from the Director of the State Politeknik of Pontianak, our representative, and officially open the international seminar. To Haji Irawan Suharto, STMT, the floor is yours.
Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wa bihi nasta'in ala umurin dawaddin. Allahumma sholli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Yang saya hormati seluruh wadir yang hadir pada hari ini, Bu Linda, Pak Dede, kemudian Ketua Senat, Prof. Nurmala, Ketua Jurusan akuntansi ya, akuntansi mesin perikanan, oke yang lain, kemudian kepala pusat ya, ada kepala pusat, kemudian yang saya banggakan Prof. Ardi, mudah-mudahan tidak berangkat lagi Prof. Ada niat mungkin ya berangkat ke Rusia ya. Kemudian kadang-kadang saya takut lupa. Kayaknya sudah lengkap ya untuk unsur pimpinan. Distinguished guests, respected colleagues and ladies and gentlemen, good morning and welcome to the International Seminar on Electrical Engineering Department with topic Smart Education in Digital Era. The seminar unites expert, researcher, and practitioner from various backgrounds, and I encourage everyone to participate actively in discussion, share your perspective, and build connection, talk, collaboration, and the sharing of knowledge. We can expand the horizons of what is achievable. Itu harapan kita sebenarnya. Ada sharing di sini, terutama teman-teman dari Politeknik Negeri Pontianak, karena saya lihat narasumber yang ada memang mengangkat materi-materi yang memang sedang menjadi topik di dunia internasional. Today, we will hear from esteemed speakers engaged in workshop and participate in panel discussion that showcase cutting-edge research and practical application. I hope you all live feeling inspired and equipped with fresh idea from your work. Itu harapan kita. Jadi ini mudah-mudahan menjadi inspirasi, menjadi apa? Nanti paling tidak ide-ide untuk penelitian, karena visi kita adalah visi menghasilkan lulusan yang mampu bersaing di tingkat internasional. Itu harapan kita. Karena yang hadir di sini bukan cuma dari Pontianak, mungkin dari Sambas juga, Pak Hasan ya. Sambas, Ketapang juga ada hadir. Mudah-mudahan ini menjadi ide setelah kembali ke kampus masing-masing untuk berpartisipasi, malah lebih jauh menjadi narasumber. I want to express to sincere gratitude to the organizing committee, our sponsor, and each of for being here. Together, we are not only advancing our field, but also contributing to more sustainable and innovative future. Dengan menyebutkan nama Allah, Bismillahirrahmanirrahim, saya nyatakan seminar internasional di jurusan Teknik Elektro dengan topik Smart Education in Digital Era, Integrating IoT and AI for Ancient Learning Experiences, saya nyatakan dibuka. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Haji Irawan Soeharto STMT as the representative of the director. And the next agenda is a group photo session. We please all the committee to join and manage this photo group session. Thank you. All the committee maybe can join. This session will be group photo. We'll taking a photograph. Foto bersama Bapak Ibu. Ya. Kepada kakak-kakak panitia, dimohon untuk memanage bagian depan. Terima kasih. Peserta mungkin diharapkan berdiri sebentar untuk mengambil acara foto bersama. Ya, baik, semua tersenyum. 1, 2, 3. Sekali lagi. 1, 2, 3. Lokasi. 1, 2, 3. Polnet mantap atau gimana Bapak Ibu? Oh, sudah. Ya, baik. Terima kasih. Silakan duduk kembali. Thank you for the director or the representative who attended for this occasion, and the deputy director and all the head of department. We say special thanks for attending this seminar. Thank you. Dear ladies and gentlemen, and now we will take a 15 minutes coffee break for you to relax, and please enjoy the snacks and coffee served. Thank you. Jadi Bapak Ibu, kita ada sesi coffee break sekitar 15 menit. Silakan untuk menikmati snack dan kopi yang tersedia. Terima kasih. Belum, Pak.
Politeknik Negeri Pontianak merupakan salah satu perguruan tinggi vokasi yang ada di Kota Pontianak. Politeknik Negeri Pontianak menempati area seluas 6,3 hektar di tengah Kota Pontianak, Provinsi Kalimantan Barat. Politeknik Negeri Pontianak dulunya dikenal dengan nama Politeknik Universitas Tanjung Pura, yang pada awal berdirinya hanya memiliki 2 jurusan, yaitu Teknik Sipil dan Teknik Mesin. Politeknik Negeri Pontianak memiliki 8 jurusan dan 25 program studi di kampus utama dan 12 program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD di Kabupaten Kapuas Hulu dan program studi di luar kampus utama atau PSDKU di Kabupaten Sanggau dan Kabupaten Sukamara. Berikut ini 8 jurusan pilihan dan 25 program studi yang ditawarkan di kampus utama. Jurusan Teknik Sipil, jurusan Teknik Mesin, jurusan Teknik Elektro, jurusan Akuntansi, jurusan Administrasi Bisnis, jurusan Teknologi Pertanian, jurusan Ilmu Kelautan dan Perikanan, jurusan Teknik Arsitektur. Selain itu, Politeknik Negeri Pontianak mempunyai beberapa program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD, dan program studi di luar kampus utama atau PSDKU. Seluruh komunitas Politeknik Negeri Pontianak dalam rangka memberikan pelayanan maksimal kepada seluruh peserta didik sehingga Politeknik Negeri Pontianak menjadi sistem pendidikan tinggi vokasi yang menekankan penguasaan dan pengembangan ilmu pengetahuan dan teknologi untuk mendukung era industrialisasi. Politeknik Negeri Pontianak memiliki komitmen penuh untuk senantiasa meningkatkan fasilitasnya demi mendukung penyelenggaraan pendidikan dan pengajaran yang unggul untuk para peserta didiknya. Untuk mengoptimalkan proses pembelajaran yang menitikberatkan pada penguasaan nilai praktik demi mendukung teori yang dipelajari, setiap jurusan di Politeknik Negeri Pontianak dilengkapi dengan fasilitas sarana dan prasarana berupa laboratorium dan bengkel yang dapat mendukung bidang ilmunya masing-masing. Mahasiswa Politeknik Negeri Pontianak akan menjalani hampir 60% dari masa studinya dengan praktikum di laboratorium ataupun bengkel untuk menerapkan ilmu dan mengembangkan keahlian mereka sebagai fokus utama dari konsep pendidikan vokasi atau keahlian. Selain itu, Politeknik Negeri Pontianak juga dilengkapi dengan berbagai fasilitas lainnya seperti ruang kelas yang representatif, internet nirkabel, perpustakaan, poliklinik, lapangan olahraga, asrama mahasiswa, bank, masjid, ruang rapat, gedung aula terpadu, dan Polnetmart. Politeknik Negeri Pontianak juga berperan aktif dalam penelitian dan pengabdian pada masyarakat. Berbagai kegiatan telah dilakukan, seperti pemberian pelatihan bagi masyarakat yang membutuhkan penerapan teknologi, pemberian bantuan alat, dan kegiatan-kegiatan lainnya. Sebagai lembaga yang memiliki komitmen tinggi untuk menjalin kerjasama nasional dan internasional, Politeknik Politeknik Negeri Pontianak telah melakukan berbagai kerjasama dalam bentuk seminar dan konferensi internasional serta kuliah umum di mana narasumbernya berasal dari berbagai negara. Politeknik Negeri Pontianak telah menjalin kerjasama dengan beberapa perguruan tinggi, baik perguruan tinggi di dalam negeri dan di luar negeri, pihak pemerintah, perusahaan, dan industri, serta asosiasi.
Ladies and gentlemen, thank you for waiting. And we cordially invite you to have a nice seat and back to your position because in a few minutes, this session will proceed in no time. Thank you. And distinguished guests, ladies and gentlemen, welcome to our main agenda. The seminar and discussion session will be handled by the moderator. And we cordially invite me, myself, Jajang Nur Alam. And before that, good morning, ladies and gentlemen, distinguished guests and esteemed college. It is my pleasure to welcome you all to the international seminar. A warm welcome that is joining us online as well. We hope that in the future you all have the opportunity to join us in person here or offline in our beauty city, Pontianak. And I am Jajang Nur Alam, and I will be the first moderator for today's event. And before we begin our keynote speaker's presentation, I would like to address a few important points to ensure our event runs smoothly. With all due respect to our esteemed participant, first, please ensure that your mobile device are on silent mode. Silent your devices. And for the second, and for those joining us online, please keep your microphones mute unless you're speaking. Minta tolong di mute yang join di online, kecuali dalam keadaan berbicara. And then additionally, during the presentation, participants are welcome to submit the questions through the chat box. Jadi kalau ada yang mau bertanya yang via online, silahkan chat saja di chat box. Kemudian I will assist in conveying your question during the question and answer session. Okay, so let's begin our seminar now. I would like to invite our first keynote speaker. Oh, he's here already. Mrs. Mariana Syamsuddin, PhD. Good morning.
Morning, Pak Jajang. Good morning, everyone.
Okay, it is my honor to introduce our first keynote speaker. And we are delighted to have you here, Ms. Mariana. And then is distinguished senior lecturer in the Department of Electrical Engineering at Politeknik Negeri Pontianak with over 15 years of experience. She's also currently the head of Informatic Engineering Study Program. And she obtained her PhD degree from Asia University in Taiwan. And her research focuses on power quality disturbances using deep learning techniques for signal and image data sets. So in today's seminar, she will be discussing on power quality insights, tracing signals to images using deep learning for accuracy enhancement. Mrs. Mariana, you have approximately more about 25 minutes for your presentation, and then we'll be followed up by 20 minutes Q&A session. Are you ready for the presentation? Okay. Let me do like home a little bit. Roses are red, violets are blue. Miss Mariana, please go ahead. The screen is now for you.
Thank you, Pak Jajang. Handsome. Okay. Thank you, everyone, for coming, for attending this international seminar held by Electrical Engineering Politeknik Negeri Pontianak. It's such an honor for me to present the material today entitled Power Quality Insight Tracing Signal to Images Using Deep Learning for Accuracy Enhancement. Since that this area sits on the intersection of power engineering and artificial intelligence. And we will discuss this topic related to data analysis. So as we know, my talk will be separated into 5 parts. First, about electric power, and the second, power quality disturbances. The third is about existing research, and the fourth, proposed solution, and the last, result and conclusion. As we know, in the modern era, maybe it's we can hardly imagine that if we live without an electricity, since that we need electricity to power our electric devices, such as our phones, computer, or maybe now we have electric transport that need power by electricity. And more importantly, we need to power our home buildings and factories. Even educational sector needs electric power. But the big question remains that, does the power we use serve our needs properly or without interruption. Maybe we didn't aware that we didn't serve by the properly electricity. Since some of us maybe ever face that at home, they see that the flicking in the lighting. Yes, of course. Yeah, that's one of the power quality disturbances issue. So the interruption in electricity supply is caused by many issues, and such as a voltage sag, voltage swell, and voltage flicker. As I said before, that flicking in the lighting, it's a kind of impact from the voltage flicker, where it happens when there is a fluctuation in the voltage. And for voltage sag and swell, that's condition happen when there is a drop or rise in the voltage. And also for unbalanced load, we will face it in the maybe we ever face the situation suddenly our devices shut down immediately without and we don't know what it caused by. So of course the electric power interruption have the drawback that can lead the equipment damage, increase downtime, especially happen in the industry because we need to repair our electric devices, and increase maintenance costs because the frequent power disturbances happen. So we need the frequent maintenance for our electric devices. So we need to spend more costs for that activity. And of course, it will be impact to reduce operational efficiency and reduce lifespan of equipment. So what solution will be implemented, or what will we do? In this situation, we need to conduct a power quality disturbances analysis. So after we got the analysis, we can identifying the sources of this issue, and finally we will implementing reliable solution to improve operational efficiency. Before we propose our solution, we of course we do some research to the previous research that state that many articles have investigated the potential of deep learning approaches for defining and categorizing various power quality in smart grid. And another research tells that the enormous quantity of data, the problem of training time is restricted topic in prior research. So from the limitation of the previous research, we propose solution with convolutional neural network as the classification algorithm to assess the power quality disturbances issue. So as we can see here, We will use power quality data set, and we will analyze with two type of data set. First, it's the one-dimensional or signal power quality disturbances data set. We use two kind of data. First, original data, and the second data we will adapt with the noise. And after that, we will compress the data before we implement in convolutional neural network classification. And the second one, we will use two-dimensional or image power quality data set. We will use a training deep learning model, and after that we will improve it with train model evaluation before we use the CNN classification to see the performance of classification of power quality. For dataset itself, we will generate from the IEEE 1159 standard. This we generate from the mathematical formula until we get this signal. Here the data set that we use in this examination. We use in total 154,000 data set, and we also contaminate with the Gaussian noise, white noise with the 40 dB SNR and 20 dB SNR. We use three algorithm data compression method, such as wavelet transform, CNN, and autoencoder, before we pass this data into the classification method. Here the structure of the classification. In general, we have three parts of this structure. The first structure is the input, including the data pre-processing, where we, from this into this one, where we use the 15 type of power quality disturbances data set. And after that, we did the compression using three algorithms, and after that we pass the data into the convolutional layer in the feature extraction stages, and finally we pass into the classification stages, and we get the performance of 14 power quality disturbances classification. So we got the result that, of course, the data without noise, so the accuracy is better than the data that already we are contaminated with the noise. But this method showed good performance for CNN algorithm. Oops. Even for the data that we contaminate with the 20 dB noise. As information that when we contaminate the data with 20 dB noise, it means that only 20% of information valuable information that we can gather from that data. So after that, we find another gap from the previous research that CNN that usually power quality classification using one-dimensional data set to analyze. So we try to examine evaluation 2D data set for power quality, because from the previous result, we can conclude that the image can include more information rather than one D signal data set. And it will gives good feature diversity and leads to creation a good model. This is the scheme that we use. In this research, we didn't use 14 classification of power quality disturbances, but we use only 5 class of data signal. Here we separate the data into 80% for training data and 20% for validation data, and the rest for testing data. After that, we evaluate in train model evaluation to get the performance from accuracy, recall, precision, and F1 score. As we can see from the research previously, we can make comparison that the accuracy for 1D signal with 20 dB, it's set on 98.25, while the regulated 2D image matrix 99.97, and for the real data 98.99. This is we can see the differences. The synthetic data get the higher accuracy rather than the real data. But for evaluation, real data, it's quite good for the accuracy. This kind of data set, 2D data set that we use, it's we separate into 5 disturbances: normal, harmonics, third harmonics, 5 harmonics, voltage dip, and transient. To improve the accuracy, we analyze with the pre-training algorithm. So from the previous stage, previous method, we include this part as a pre-training stages. So we analyze using ResNet 50, MobileNet, and EfficientNet BO. And we also do an advancement for pre-training model. This is the best model, and we include the global average pooling and dropout layer, also batch normalization to get a good performance in classifier. And finally, before we decided which pre-training algorithm that we will use, we consider about this data. Why we choose ResNet 50, MobileNet, and EfficientNet BO? Because the depth of analysis and the size, and also the time for computation. So we got the improvement by using pre-training algorithm. From the training accuracy, it can see that the EfficientNet BO got the 99.55% as the highest one. And the result show that the highest accuracy after testing stage so by the ResNet 50, 99.55. And this is improvement from the basic CNN without using pre-training algorithm. So from the journey of the analysis, the power quality disturbances from the one-dimensional or signal to one-dimensional, we can say that the power of one-dimensional can improve the power quality analysis, that enabling system that can more accurately detect the disturbances and diagnose the quality issue. And the aim of this research is to maintain the quality of power distribution, that we can hope it can
for the enlightening presentation. And we now have time for questions from the audience. And now I invite the participants who are present offline, actually in this room, to ask their question first. Anyone? And then followed by a participant who have joined online in YouTube channel or in Zoom meetings. Oh, there's a question. Okay, first question. Thank you. And please state your name and affiliation before asking your question. Thank you.
All right, so thank you for the time. My name is Risa Fitria Syafutri. I'm from Architectural Engineering Department, Politeknik Negeri Pontianak. So my question is, well, first thing first, it's a very interesting topic, especially for us in architecture engineering. We understand the IoT application for smart buildings, right? And you mentioned before that this technology can be applied to PLN, let's say it's a big company. But what about the simplified application in our daily life? Is there any relevancy or something? Thank you.
Thank you very much. Okay, should we answer it first, or anyone who want to ask a question? Another question, maybe? Okay, I think we should answer this first question. So, excuse me, what's your name?
Yeah.
And the name.
Risa.
Lisa.
R.
Risa.
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 Yeah.
Okay. Mrs. Risa. So your question is the simplified to our life relevancies
Exactly.
with okay.
Okay, thank you for the question, Ms. Risa. Actually, for this research, it can be implemented to smart grid, especially for smart grid, since that previously, traditionally, grid is only has one flow from the power plant, transmission, distribution into the consumer. But now with the smart grid, we have to we have this application. So the consumer, from the consumer, the data can send from the consumer into the data center from the electrical industry. So that can be the feedback from the consumer. But for data analysis itself, of course, it can implement to your major, especially for the architecture. We can learn from the behavior of the buildings, which maybe it's the building needs more light or need more circulation, by identify a number of participants in that room. Yeah, it can be analyzed using the data analysis, using an algorithm. We can make a prediction by using prediction algorithm, or make a classification in that room. It can be analyzed using the data algorithm, using an algorithm. We
Okay,
can make
advertisement.
a prediction by using prediction. Okay. Does it meet your question?
Yes, thank you very much.
Thank you.
Okay, thank you very much, Mrs. Risa. Okay. And then we're going to say hi to participant in online on YouTube platform and Zoom meetings. Hello. Maybe the participant from online platform want to asking a question. So
Hello.
just type the question and immediately Mrs. Mariana.
Jajang is the best teacher.
So anyone want to ask a question? Okay. Thank you for the participant who joining us in the Zoom meeting. Maybe there is a one or two question from Zoom meeting. Maybe we can check the comment section. Just raise hand in the Zoom apps. Maybe you can raise your hand in Zoom meetings. So we can maybe invite you to join us in the meetings. Right. Okay. So before we say hi to another participant in online platform, so I want to like ask simple question, because actually I don't really get to this topic because I'm not in electrical department. So I just want to ask you, like, ask Miss Mariana like a simple question. What is meant by how we manage the flickering in the lamp like this, like in this room? Yeah, maybe in our room or our bedroom, we can face like every time we meet like unbalanced load, maybe it would make the lamps like always flickering like that. How we manage the problem like that?
Okay, thank you. It's an interesting question. First, we have to know we have to identify the resource that can make this issue, the flickering in the lighting. It can be there are a drop in voltage or fluctuation in voltage, and it also can be from the unbalanced imbalance load. Yeah, in the three-phase system, in the three-phase system, we should separate the RST phase in the balanced load. But usually, a technician in the site maybe didn't concern about this. So maybe a consumer in the R phase more rather than another phase. So it can be make the like unstable voltage. It's based on my experience actually.
Okay, thank you, Ms. Mariana. It's
Also face that situation in my home.
yeah. It always happened in my actually bathroom. So I thought it was like from the water that we take a bath. Like wow, it's kind of like a short circuit. Oh, I'm really scared of that because it's really dangerous when we find that our electricity has get some error or something. Like
Yeah, you should be careful.
okay, thank you, Mrs. Mariana. Anyone in this room want to ask a question? Just raise your hands. Ah, okay, thank you. Please state your name and the affiliation. Thank you. Microphone, maybe.
Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
Thank you for this opportunity. My name is Ahmad Mustangin. I'm from Agricultural Technology Department. Uh, I want to ask you, Miss, about where we can where we can meet or we can find your implement research. Your finding research in this section. Actually, in my area, maybe in agricultural technology, the implementation of your finding research. Thank you.
Can you mention again what kind of major?
My major, agricultural technology.
Agriculture.
Maybe in food technology.
Mhm. Okay, so do you mean that where we can implement this?
Your finding research.
Mhm.
In my area, in agricultural technology or food technology.
Okay. Okay, I will say that
Maybe about tool or whatever, we can use it in my area in technology, food technology.
Okay, so yeah, maybe my topic is too basic for power engineering.
Yep.
But for data analysis itself, using deep learning algorithm, it can implement more in the wide area, such as your major. For example, we can identify or make a classification of the
Maybe
food or
maybe classification about the bacteria.
yeah, it could be.
It could be okay.
Yeah, it could be. So as long as we know the parameter that you want to assess, we can collect the parameter and we can what do you want to do? Do you want to make a classification of bacteria or predicting the growth of bacteria?
Maybe the classification of a species and the functional of the bacteria.
Oh, yeah. Yeah, it's a very can implement for that. So you can arrange what kind of parameter do you want to classify as a bacteria and for B bacteria, and you can use the simple things. You can use the expert system, or you can use another classification algorithm. For your information, we ever do research for classification cancer, for yeah, maybe you can find in I forget, but for this presentation I didn't include the reference, but it's,
We can
we can do
use
that.
the data analysis
Yes,
for
okay.
our major.
Yes, yes, of
Thank you
course.
so much.
Mhm.
Okay, maybe just it. Thank you and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Mr. Mustaqim. Yes, from agricultural. Okay. And then maybe the next question, or the participant who join online, maybe all the community can check the comment section in the YouTube or Zoom meeting. Anyone who want to asking question, just raise the hands up. Again, if it's not, well, we have now reached the conclusion section. Or Ms. Mariana want to deliver something, or want to, or yeah.
Okay, before we close this session, actually I want to promote my research team, which have a same interest in artificial intelligence. We in this year, I think, in this year we already published two academic article in international seminar. First written by Ibu Sarah Bibi, and the second written by Safri Adam. The first is about the analysis of student behavior using CNN models, and the second, Mr. Adam has published the publication about the identification of what? Oh, TBC. It's the kind of disease of TBC. And the latest research about the accuracy of image processing about the for spot the error target. It's all using AI for analysis. So we are very welcome if there are some friends that want to collaborate with us. Thank you very much.
Thank you very much, Mrs. Mariana. But before we go to the conclusion, I would like to ask you a question again. Is it okay? Okay. What do you think about this topic? Maybe it's like common. It's common for you and all the lecture out there and lecture in electrical engineering. But for me as a teacher, especially in English department, so can I do this simple research for my students? Maybe I can manage to build like some application for English learning or something?
Okay, before I answer the question, this is the first time I met Pak Jajang. Pak Jajang comes from Sukamara, and this is the first time you come to Pontianak.
Yes, this is my first time actually.
Okay, so interesting. So Pak Jajang, actually we ever collaborate with one of lecture from education, Ibu Nurmala Simbolon. We are analyzing about the needs of online learning using MOOC, MOOC, Massive Open Online Course. So we also do some analysis. We can where we the question is the analysis in your major needs comes from the questionnaire. So it's a open question, and we have to analyze the question. So it's a kind of text. So we can use synthetic analysis or text mining to dig the information from the statement of respondent. It's really possible to implement the data analysis in many areas.
Okay. Thank you very much, Ms. Mariana. Because in my field, I just usually with my friend like deliver something, like just deliver it, and teach it without knowing like the utilization of AI and IoT for enhanced learning experiences can help us for as a teacher or lecturer in our teaching method. Okay, thank you very much, Mrs. Mariana. Yeah. Okay. Prof. Ardi. Okay. Want to ask a question? Like maybe a committee can help to pass the microphone to Professor Ardi. Thank you.
Thank you, Pak Jajang. Bu Ana, it was such a great presentation. I'm not going to ask a question about what you have presented since I'm not familiar with anything you have mentioned. Now, I believe that most of the participants here haven't had a PhD degree, okay? If you don't mind, since we still have time, like 40 minutes before we come to the next session with our next presenter, if you don't mind, could you please speak a little bit about your PhD journey, your experiences from how you get the scholarship, for example, and then how you can approach a supervisor, and then during the process of your PhD, what problems did you experience, and then how did you cope with these problems, and then what suggestions you can give to the participants attending here, offline or online, if they want to pursue their PhD in Taiwan, just like what you did. Thank you, Bu Ana.
Okay, you're welcome, sir. Mrs. Mariana maybe can answer the Professor Ardi question. Professor Ardi asked like tell about your PhD journey. Okay, maybe you can tell all the audience here like your journey from problem, experience, and your suggestion if all the participants here want to pursue their PhD. Okay, thank you very much.
Okay, thank you, Prof. Adi, for the question. It's such an honor for me to sit here because of his what he pushed me to sit here to be a keynote speaker. Okay, actually, as a lecturer, we are very idealist to continue when we want to continue our study. First thing at that time, I also search the best university. And the university that respond me is Queensland University of Technology in Australia. But and I also apply for the UWA, the best university in Western Australia. So all of from that choice, I also try to find the best one, but I fail many times. And someone said to me in my age, I'm not younger anymore. Maybe we have to decrease my idealism. So it's continue my study in the PhD stage is a great opportunity for me. So just take the opportunity. So don't consider about the rank of the university. So at that time, I tried to decrease my idealism and I tried to apply for many university. For the university that I complete my PhD, actually it's not my favorite university. That's coincident when I visit Taiwan for bridging program. So I met my professor with the same area and we make a little discussion. And after back to Indonesia, I tried to apply Ministry of Education scholarship from Taiwan. Since that, I really know my I'm not good in speaking, so I also fail in the interview section. So I choose the scholarship that didn't need interview section. So they only evaluate my portfolio. And lucky me, before that I ever get the student scholarship. That's I believe that if we ever get the scholarship before, it's a good point for us to get another scholarship. But another consideration, I think we have to push ourselves to make a publication, because I know that the weakness of mine, that I have a limitation publication. So I start my writing when I in a PhD program. So that's why I very suggest for you all that want to pursue the PhD program, try to push yourself to make a publication. Actually, we have done many research, but we didn't publish the result. So maybe we need to encourage ourselves to make a publication. And struggling, I think many people have the same experience with me when they pursue their PhD program. Of course, we are struggling with the research and struggling with the publication, because we have to wait until 1 and 2 years for publish our research article. Then it's also happened to me. I have one publication and it's I got the information from the journal a year after I go back to Indonesia. So it can imagine if I still wait the publication of that research, maybe I haven't finished my PhD degree. So
Bu Ana,
what else?
next question is, are you saying that in order for you to complete your PhD, you have to have your research published in a journal? Otherwise, you cannot get your degree.
Yes.
So is that part of the requirement?
Yes, yes.
Could you please tell us a little bit about what type of journal that you are required to publish your paper?
In Taiwan, we have to publish our journal in SGI index. I don't know the conversion in Indonesia, but as I know, SGI, it means that in Indonesia, it's a Scopus.
I see.
So no matter it's the Q1 until Q4, it's no matter.
As long as it is
Yeah,
indexed in SCI. Okay. Okay. My next point is, did you do your study as a full research program, or you were required to attend some classes before you proceed to your research? And then what process of examination did you go through? I mean, should your PhD thesis be examined by, let's say, 2 or 3 examiners from outside your university, or it can be from inside your university?
Okay, for the examination, before we do the proposal examination, previously we have to pass the qualification exam for our expertise. It's a minimal 6 examination. And after that, we can continue with the proposal. Proposal is examined by our lecturer and internal lecturer. And the final defense, it can be examined until up to 7 persons from inside and outside. And lucky me, for me, I got the 7 examiner.
So you have to defend your thesis before the committee.
Yes.
All right.
And before I do the research, I have to attend some courses. It's about 33 credits.
And then they were all graded. I mean, they were grades,
Yeah,
for the
grades,
coursework.
grades.
Okay. So how long? I mean, should you attend the coursework program for a year or for a semester or more?
For coursework, it's about 4 semester.
4 semesters
Semester.
before you started your thesis writing.
Yeah.
How long is your thesis? How many words?
Words?
Mhm.
Yeah, it's very interesting. In Taiwan, the words in thesis or the pages of thesis, it's depend on the how many publication that we publish. So if I rate 140 pages, it means that I have 14 publication.
14 publications. And they're all indexed in SCI, yeah?
Yes, but for international conference, it can be IE index. It can be IE index, but for the journal, it should be SGI index as the requirement for final defense.
And for yourself, how many articles did you publish as part of your PhD?
I forgot it. Maybe 7.
Wow. It's quite demanding, ya. It's quite demanding. Wow. Monggo Bapak Ibu sekalian yang mau S3 silakan. Ya, saya hanya trigger aja. Monggo silakan. I don't need one.
Okay, thank you, Professor Ardi, for the question to encouraging all the participants here to pursue the PhD title. Maybe anyone in this room? Okay. I think we should think it twice when we go to pursue our PhD title. Okay, thank you, Mrs. Mariana. Anyone? Maybe you want to asking question in online platform? Oh, okay. Thank you. There is a one, two. Okay. Please all. Okay, mention your affiliation and your name. Thank you.
Waalaikumsalam warahmatullahi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Andrian. I'm from Administration Business Department. This is interesting topic because my major in bachelor is electronics engineering. My question is, you said that your research can implement to our electricity company such as PLN. How much money you need to invest to implement to PLN? And there is still have problem with your research because we know that in reality, when we want to implement our research, we need to blend with system or already exist in PLN. Thank you.
Okay, thank you, Mas Adrian, for the question. Actually, I'm not so sure it can be implemented in PLN because we have to, due to regulation, so of course, we need a long discussion with the PLN. As information that I got, even in US, they have one application called Synergy Electric that can measure the reliability of the electricity distribution. It's really expensive. So the kind of PLN in US donate that application to the university for education. So it's a very depend on that area to implement that. As I mentioned that this research implemented in the smart grid. And I don't know exactly in Indonesia whether it is already smart grid or not. Thank you.
Thank you, Miss.
Okay, thank you, Mr. Andrian. Is it fit your question, Mr. Andrian?
Yes.
Okay, thank you very much. And then another participant maybe want to ask a question, maybe offline. Okay. Can committee pass the microphone to the students over there, participants over there? The microphone, maybe someone can help to pass the microphone. Left corner, right corner. Sorry.
Yes. Assalamualaikum warahmatullahi wabarakatuh. Thanks for the opportunity to let me ask some question. First of all, I will introduce myself. So, my name is Fadli Firmansyah, and I'm from Diploma 4 Electronic Engineering. So the first question is, how do you manage to get to the other countries? And then the second one is, do you apply for a scholarship or use your own money? And how, if you use scholarships, do you have tips and trick to get a scholarship? Thank you.
Okay, thank you. Sorry, Mr. Your name, sorry.
My name is Fadli Firmansyah.
Oh, Mr. Firmansyah. Oh, sorry. So I want to confirm that your question is how we manage to other country.
Yeah, how do you manage to get to other countries and
Okay. And tips and trick to
get a scholarship?
get a scholarship. Okay.
Yeah.
Is that all?
Yeah.
Okay,
Thank you.
Thank you.
Okay. Okay, thank you, Fadli. Fadli Firmansyah. Fadli.
Yes. Yeah.
Fadli. Fadli is one of my best student in TRSA.
Glad to know that. Okay.
Thank you. Thank you for attending this event, Fadli.
Yes.
Okay, as I mentioned before, I actually Taiwan is not my target to get scholarship, but I got the opportunity to go to Taiwan first and meet our potential supervisor, and yeah, finally I got the chance to continue my study at Taiwan. So I choose Taiwan because it's a safe country, and the people in Taiwan are very kindness for us. And how to get the scholarship? We have to upgrade our portfolio, of course, because we have to continue to abroad. We need to equip ourselves with the good ability in English. So that part is also the struggling part for me. Not like you are you are majoring in English. So it's quite difficult for us. That's not really concerned with the English before. So we have to equip ourselves with the certificate of English proficiency. So I spend many time to to train myself to get the score that can meet the requirement. And yeah, maybe Prof. Ardi still remember. Prof. Ardi is also one of my mentor. I don't know since many years ago, yeah, Prof. Yeah, I think that's it, Fadli. Keep spirit.
Okay, ma'am. Thank you.
Okay, thank you very much, Mr. Fadli Firmansyah. I hope maybe someday you will get your first scholarship, or maybe you can go abroad somewhere, Taiwan or Canada. Maybe you can choose the other countries.
Amen.
Amen. And maybe I want to like give an additional since Miss Mariana told me that I'm good at my English. I'm not so good in my English. Just because I'm in English department, it's not totally all the students in English department can could speaking like maybe I'm going to earth first like me, because I think the motivation is the key. I can speak like this because I keep learning and keep motivate myself with many resources like watching movies or listening to the songs. And yeah, maybe from any platform we could learn English from YouTube or something. So in this modern era, I think it's easy for us to learn English. Furthermore, we have AI. So in my thesis journal. I use AI also in my writing my thesis. I use like Grammarly application for the made the grammar like correct, and to paraphrase something, to paraphrase I use quillbot.io. So it will it made me easier to doing something like paraphrasing or something. So it's depends on the person. If they want to pursue their dream, so they can. Okay, thank you.
Thank you for the sharing. Okay, maybe I want to share one tips that can improve our portfolio or our application for pursue our PhD. So in this event, we can meet many people from another country. So please keep contact with our keynote speaker, because we after this seminar we can still communicate with them, and maybe we can continue our collaboration with the research collaboration. And maybe sometimes our keynote speaker can be our international research advisor. So it's really good things, yeah, valuable things for us, since that when we want to apply for PhD degree, we can ask them to give us a recommendation letter. So yeah, that's will improve our application.
Okay. Thank you, Mrs. Mariana. Maybe that's a little bit tips and trick for me and Mrs. Mariana. Maybe want to join or to get your first PhD title, maybe. So we can move to online platform. I found the one or two question from the online participants. Sorry. Can we like zoom a bit? Zoom in. Okay, thank you. Okay, from Amanda Safitri. May I ask about the I ask about the composition of training data? From your explanation, validation is 20% and training and testing data is 80%. If we change the composition of validation data and training data, can we get a better result? For example, I change the validation to 30% and training and testing data to maybe she means like 70%. What do you think? Okay.
Yeah,
Thank you, Mrs. Mariana.
Yeah, of course, we can change the portion of the training data and validation data. It can be 70 and 30, 60 to 40. And in my research is 80 and 20. So before we got the conclusion that the 80% for validation and 20% for training or vice versa, we do many possibility until we got the the best accuracy, which portion that will support the accuracy, a high accuracy. So it's really possible, and it's also we also done that the stage. We make a different portion until we get the best portion for the validation and training data.
So thank you to the participant who joined in online platform. Maybe anyone want to ask a question in this room, ladies and gentlemen? Okay. Maybe the committee can check the YouTube channel. Maybe there is a comment section. There's no question anymore? Okay. Thank you. Please state your name and affiliation.
Okay, hello. Good morning. My name is Irene from Civil Engineering. Actually, I would like to ask about your PhD journey. And from your explanation before that, you said you have some course, bridging course, right? And then you've met the, how to say, professor in there. And so I would like to ask, so it's mean like, sorry, I'm a little bit nervous. So it's mean like you don't have prepare about a research proposal before to apply the scholarship, or you need the research first, because because you already met the professor before, so is it really needed for the research proposal or not? And then if it needed the research proposal itself, so can you give some suggestion for us how to make a research proposal that can make the professor really want to choose us as his student. Thank you.
Thank you, Mbak Iren. First time, of course, we need to prepare our proposal. So when we come to the professor, we already settle with our planning, but the advice from our supervisor, of course, it will enhance our proposal. So the needs for the PhD proposal, of course, the novelty. But I think that, for example, in the uniqueness from civil. Oh, okay. I try to find what kind of in civil engineering, what kind of subject that we can propose as a research, Mbak?
So many, see, but I mean, yeah, it's about earthquake maybe, yeah, or about the how to say it, concrete, or about steel. Yeah, it's many things that we can make it as a research, but yeah, but I just want to know the suggestion from you for, I mean, just for the common research proposal, not just the civil engineering.
Oh, okay. Yeah. I just got an idea for concrete. Maybe in civil engineering, maybe implement algorithm from computer science will be a good improvement for civil engineering. For example, when you want to analyze the concrete, you can use from computer science algorithm to analyze the crack from the concrete. For example, using prediction algorithm, so you can predict how many years this building will stand, and yeah, you can modify the algorithm to enhance the research. For example, like that. So yeah, like in yeah, maybe in computer science, the algorithm is a common algorithm, but when we combine with another major, it can be a very valuable research. Yeah, for example, when we use the algorithm to measure the pressure of our the pressure from the shoes, using YOLO algorithm for medical treatment for someone that get the leg disease. That can be a good research in the area of medical student. But in computer science, YOLO algorithm is a common algorithm. So maybe you can combine the another your topic with computer science analysis. Maybe can improve the research.
Okay, Miss Irin, is that fit your questions?
Yes, absolutely.
Okay.
Thank you.
Thank you. You're welcome.
Thank you.
So the point is have to prepare for our research. I mean proposal, and absolutely the proposal should consist of first is novelty, and then uniqueness. Maybe another one, Mrs. The important thing, collaboration. Okay, so it's very important for us to prepare the proposal if we want to get our first PhD, like uniqueness and then novelty, and then we should do more collaboration. Okay, thank you. Okay, we are going to see our attendees or our participant in online platform. Is there anyone join in the online platform? Okay. Again, if it's not, we have now reached the conclusion section. From what Ms. Mariana has presented and the subsequent and question and answer session, here are the key takeaways from her materials. And Mrs. Mariana research has demonstrated a deep understanding of power quality disturbances in electrical system. I mean, like power quality disturbances, like lightning, like flickering or something. And then the study successfully utilized deep learning techniques to enhance accuracy in signal and image analysis related to power quality. And third, this research has shown practical benefits in improving the efficiency and reliability of electrical power systems. And absolutely, Mrs. Mariana presentation has provided us all with valuable insights into the latest developments in the field of power quality and analysis using deep learning techniques. Once again, thank you, Mrs. Mariana, for your significant contribution to this seminar. Let's give a round of applause for Mrs. Mariana. Okay, maybe before you left the room, you have one or two word for. Oh, okay. Saya tanya punya pantun atau tidak? Can you say pantun like walking? I don't have any pantun anymore. Okay. Thank you. I will hand over the role of moderator to me myself before we go to the next session. Before that, Ms. Mariana, maybe you can leave the room. Okay, thank you. If you want to join with me here. Oh, okay. And now I will hand over the role of moderator to myself. And I will guide through the next session of our International Seminar of Electrical Engineering Department with Dr. Seng Chong from, sorry. Okay. We just waited Dr. Seng Chong to join us in online platform in Zoom meeting. And before that, Dr. Seng Chong is a distinguished academic affiliated with the Montfort University. Okay, thank you, Mrs. Mariana. I thought you will join me. No. Okay. Okay, it's my pleasure to introduce our second keynote speaker, Dr. Seng Chong, who is a distinguished academic affiliated with the Montfort University in Leicester, United Kingdom. And his expertise lies primarily in the fields of information systems and technology, and absolutely focusing on areas such as data analytics, business intelligence, and digital transformation. Dr. Seng Chong has contributed to various research projects and publications, emphasizing the application of technology in enhancing business processes and decisions making. And his work often intersects with the practical implication of emerging technologies in contemporary organizational settings. Is Dr. Seng Chong join us already in online platform? Not yet. Okay. Okay, before we go to the next session, we have a short break while waiting for Dr. Seng Chong to join us. Okay, thank you. See you in next session. For all the participants who have the snacks already, maybe can enjoy the snacks and drink served. Thank you. Okay, ladies and gentlemen, we cordially invite you to have a nice seat and back to your position because in few minutes the session will proceed in a time with Dr. Senchang. Hello, good morning, Dr. Senchang.
Hi, Doc. Hi, good morning. How are you?
Good morning. I'm good. I'm really good. Dr. Senchang, how are you today?
I'm fine, thank you. I'm actually in China now.
Okay, it's okay. Okay, Dr. Senchang, now before that I will represent you to our participant today.
Okay.
So now it's my pleasure to introduce our second keynote speaker, Dr. Senchang, who is a distinguished academic affiliated with the Montfort University in Leicester, United Kingdom. And his expertise lies primarily in the fields of information system and technology, focusing on areas such as data analytics, business intelligence, and digital transformation. And Dr. Senchang has contributed to various research projects and publications, emphasizing the application of technology in enhancing business processes and decisions making. His work often intersects with the practical implication of emerging technologies in contemporary organizational settings. Without further ado, I invite Dr. Senchang to deliver the material. Please give him a warm round of applause.
Thank you very much for the introduction. Yeah.
You're welcome.
Okay, so let me share the screen. How come okay, here you are. Okay, so how long should you want me to talk about the speech? May I know?
Okay, sorry, for 25 minutes, and we will be next decision with the
you want me
question
to
and
just
answer
speak for
session.
25 minutes, yeah?
25 minutes, yes. And
So
for
I will
the
finish at, okay, 11:15, yeah?
11:15. Okay.
Oh,
It's good.
okay. So 25 minutes, I need to monitor my time. All right, good morning, everyone. Welcome to my speech. Okay, I'm not, the way I look at it is I've been working on this Internet of Things for 3 years. I'd like to share my experience with you. Basically, I'm more like an educator, so I educate students. Yeah, so my speech is about how I integrate the IIoT module, yeah, in the engineering syllabus, particularly for mechatronics. I'd like to share with you my insight and experience. Okay. So this is the module called Industrial Internet of Things. Yeah, and you can see that I'm teaching this. And what is Internet of Things? Okay, basically, you know, we are like human, we are connected via the mobile phone, we are like Internet of Human. Whereas now things need to be connected, yeah? With the connection, if things are connected, we can monitor them, we can control them remotely, we can gather data from the things, which is everywhere, and also, yeah, we can, with those data, you know, it fit into the big data, and then, you know, a lot of things, a lot of usefulness like, you know, data analytics, and then on the higher level, you got the artificial intelligence. Okay, so the key feature is connectivity, data collection, automation, remote control, you know, example like smart home, wearable, smart city. Whereas industrial Internet of Things, it focus on industrial sector like manufacturing and energy to improve efficiency and reduce downtime. Yeah, so you're focusing on industrial application and more advanced data analytics, particularly for predictive maintenance. Yeah, you want to maintain stuff before it fail. Real-time analytics and also machine learning. Okay, you want machine-to-machine communication because downtime, you know, in industry, every every second count. Yeah, any downtime will be very costly because it affects the whole plant operation. Safety efficiency, also on safety. Yeah, so this example like predictive maintenance, smart factory, where you send data to the business layer. Okay. So the difference between IoT and IIoT is the broad application on IoT, whereas IoT focus on industrial use cases. IoT is large-scale system, higher security and reliability. IoT is less complex. Yeah, use of data more for convenience and automation, whereas IoT, big data, machine learning, and stuff like that. So when we talk about this Internet of Things, we have these 4 stages of architecture. So the architecture can divide into 4 stages. At the bottom is the sensor and actuator. Yeah, so this is building up from the bottom. Okay, and then you have this data gathering layer. And then we have this edge IT. So it's like, before you go to the cloud, on the surface, sometimes they call it fog. Yeah, because before you cold enough to get the cloud, you have the fog layer. Yeah, so this is at the edge. Yeah, so you have the local processing on site. Yeah, on site. Then you send data to the cloud. Okay. And you have this 7 layer of architecture. So those are 4 stages. They have this. They divide it into 7 layers. If you look into it, there's actually some overlap. Yeah. So you can see there's some devices, controller, connectivity, and edge, which is the same like the one HIT before. And then you got the storage in the cloud, and data extraction, analytics. Yeah. So you process the data, you have the analytics, you have the collaboration process, enable you to do, this thing, yeah, and the application. So you build application on top of those cloud, and then on top of the application, you have this business layer, yeah. So the business will get the data further, yeah, for like example ERP, that kind of enterprise business application, yeah. So on top of that, you have security. So these are 7 layers. IoT is enjoying a lot of, it's a high growth market. Yeah. So you can see manufacturing accounted for 64% of the market share. Yeah, which is not 64. Sorry, professional service company catering for specific. So they have high needs for this. Yeah, some of the leading firms are this. You can find plenty of international, company active in this sector. Yeah, so you have the application like smart cities, smart agriculture, smart transportation, energy infrastructure, smart home, smart health, smart industry, yeah, city service, all rely on the IoT capability. Okay. And on the business layer, yeah, so you can see this is another picture depicting the sensing layer, also called the perception layer. So where you feel, yeah, or gather or sense data. Okay, and then you can see the edge and fog again and the cloud. Yeah, so that's our 4 stages of architecture, but divided into 7 layers. Yeah, so you can see the cloud layer will encompass the application layer and the business layer. This is just a way, or we call that a reference architecture for developer to understand, where they are operating and what they need. Yeah. So by building on layer and by layer. So where is this coming from? We were motivated to create this module is because we have this industrial liaison committee in the university, led by Mr. Scott Turner, who is the European solution architect and project consultant from Amazon. Yeah, Amazon is an international company, and their core business is about this kind of Internet of Things solution for manufacturer. So it's really driven from the industry to see our syllabus that we require this Internet of Things. Yeah, how it shaped the module. basically is a curriculum is relevant to the industry. We have the expert input from them. Mr. Turner provide us with guest lecture, and then with some real world assessment and continuous feedback. Yeah, so they come to our session. They look at the work produced by the student. They support project as well. So the learning outcome about this module is knowledge and understanding of scientific principle and methodology. Yeah, the hardware, the software, the application, ability to apply the integrated knowledge and understanding of other engineering disciplines, either to carry some research, design and development of the IoT system, and able to use controller, yeah, controller like Arduino and Raspberry Pi. So the module plan include introduction, IoT architecture, electrical platform production, cost projection, hardware protocol element, case studies, yeah, communication modules, Wi-Fi, MQTT, that kind of thing, security and cybersecurity, database implementation, machine learning, analytics for IoT, yeah. And then we have practical session each week, okay? So like introduction, how you install the architecture, ESP to Arduino IDEO, okay, IoT platform, adding some component, add more component, new sensor, okay, integrated IoT system, and so, and then you have other labs where they complete the work. Okay, so this is they need to produce some sort of proposal document. The reason we need to produce a proposal is because this is very much aligned to, example, the student, if they go to the industry, yeah, they need to propose a solution, and to do that, they need to consider things like introduction, background, yeah, problem statement, yeah, aim, objective, methodology, the reference architecture, the design, project benefits, feasibility, limitation, resources, cost, return on investment, okay, the schedule, the deliverable, the milestones, successful criteria, and the implementation, yeah. So they need to look at it as like a proposed solution for the industry, yeah. It could be in-house, yeah. It could be they are a subcontractor for a project, or they can be a project engineer, okay. And then they need to implement that a proof of concept, yeah, to demonstrate that it's working. So it's not a full-scale working prototype, but a full concept, and then with discussion and conclusion. And then in terms of marking scheme, they need to produce, yeah, you know, this is for the presentation, which is 25% of the module. So what is special about this proposal coursework? Yeah, so very much aligned to, you know, there need to be a proposal format, a hands-on prototype, which is 50%, you know, in research on, return on investment, that kind of thing. So the business aspect should be there, yeah. So the coursework, yeah, so 25% proposal, 25% presentation, and so in total, the weighting is 50% and 50% of proof of concept for the whole thing. Okay, so over the 3 years, we have this proposal for transforming the existing manufacturing facility into IoT smart manufacturing. This is the year one, first year, and the second year we have this development of an IoT prototype for a typical Indonesian shrimp farm. Yeah, this is inspired by our colleague Dr. Danny Hamanto. Yeah, he told me about this, and then I'm using this as a case study. And then last year I used a IoT solution for vehicle and machinery modeling with GPS and motion sensing, which is a very useful project. So for example, if you have manufacturing vehicle, yeah, you will need this Internet of Things. So you try to encourage the student to think outside the box, where they develop a box that can, integrated to the machinery. Yeah. For example, they will gather acceleration data, motion data. You can gather GPS sensor. So the hardware we use include ESP32, which is the main controller. You got the GPS sensor there, where you can monitor this, and MPU 6050. You can have monitor the acceleration, and LDR detect operating environment. DC motor is for provide actuation, thermistor, etc. Yeah, so these are hardware. ESP32, why is because it's quite a versatile, is cost effective, it's cheap to get. You have the development capacity which is rich. Yeah, so if students want to understand or how to implement certain things, there are plenty of documentation online and example. Yeah, you got project management feature, multiple I/O, quite a very capable processor at a very cheap price. We have this GPS sensor, yeah, and MPU 6050. Why MPU 6050? Because it's also another very cost-effective sensor, and it gives you this gravitational acceleration, gyroscope measure, yeah, also measure the temperature, etc. And it's using a very simple interface, yeah. Whereas the GPS sensor, yeah, they will give you different data. So why is it important for monitoring on vibration? Yeah. If you look into this, yeah, machine health, time to failure, as time progresses, yeah, you got this under the warranty ongoing fault, and then you got the vibration, yeah, and also you can use a microphone to make, because noise, when the machine about to fail, it create a lot of noise as well. Yeah, and then you got this temperature sensor. It's a very simple sensor. If you machine overheat, yeah, you can detect failure. Also the machine fault, yeah, percentage of occurrence of machine fault, a lot of time is local related fault, yeah, or bearing fault. Bearing fault create a vibration and then the noise. Okay. So vibration and temperature sensor for prevention is very useful. Okay. And some company actually provide this kind of boxes where you can add to the operating machine or motor to detect failure, send data. Okay. So in terms of the laboratory work, basically you're familiar with the ESP32, add the sensor and actuator, implement cloud, and do the data analytics. So this is the cloud. It's a very good simple example from the data gather at the beginning, and then you can do some data analytics. Digital twin is a concept where the student will also explore, yeah, in terms of, you create a digital twin, and then which is the a simulated model of the system, and then you have the real system. So the real system data collected from the real system will fit into the virtual model for analytics, yeah, and also improvement of the model. And if the model detects something wrong, yeah, they can feed it back, for example, to stop the machine. Okay, so Emerson is behind this company that help us or support us, which is really important. So this is what they are doing. They got different layer as well. They call it Prime Web, where they offer a big range of services, different sensor, and also how this analytic tools is divided. So this is company literature. Of course, it's a company where you can provide a complete solution if you were to invest into it. Yeah, so very important. Also, this digital twin concept is supported by MacLab. Yeah, this is one example where company on this machine is called the Palm. Yeah, it's a Palm. So this is a virtual model, and you can collect data. A company like Rolls-Royce, yeah, when the airplane is flying, they are monitoring the engine all the time. Yeah, final year project example would be like this. Yeah, which is quite common: smart home air quality monitoring. So these are some of the projects that has been done by my student. This is inspired by the stream from monitoring. So and for this another inspiration from my colleague is the water quality monitoring. So my student developed something like this, and then he tested at night to monitor water quality like pH, the water quality, like whether it's muggy or not, whether it's clear, okay, and the temperature, yeah, and oxygen level. This is fun. This is my student working on a robot, yeah. So this robot doesn't have IoT capability, so he's adding the IoT capability onto the robot, yeah. So this is quite interesting thing. So he did the two very important thing is to monitor and control the robot remotely, and then he actually attempted the digital twin. So he has the model in capillary sim, and then this real robot. So through MATLAB and Simulink, he gathered the data and fit into the capillary sim. I'll show you very quickly what he's done. Yeah. So hopefully it play. So this is monitoring. Yeah. So monitoring the, and here quite a good interface. Different value. How the robot operate. Gathering the data, displaying on, this is on the cloud. Yeah, this is on the cloud. And this one is on the attempt on digital twin. So this real system, and then he got this model, which is a capillary sim, which is a virtual model. So there is a lag because of the communication. So when the real machine is running, the virtual model also do the same movement. Okay, so you can see that there's a link between the real system and the virtual model. I have students working on this is tracking. Yeah, tracking. This is a project also supervised by Emerson. Yeah, to see if you can actually monitor something very remotely. Yeah, you're talking about using this kind of Sigfox, yeah, and low energy Bluetooth. Okay, so this is another student, MSc student working on a predictive maintenance system. Okay, so some of his work, and he's using something called the Edge Impulse, yeah, which is a machine learning platform, which is available. So it's moving into, once you gather the data, you want to work out which one is actually having so predictive maintenance, cloud stuff, yeah. So quite interesting. Okay. Sorry about the noise. Actually, we have not just DMU student, we also working with APU, Asian Pacific University in Malaysia. So a lot of the student is working on this kind of, they are also using this module. And also we have partner in, it's called in Sri Lanka, the student are also using this module. And then they actually work on the number of student project is vast, yeah. So not just on this Internet of Things. Okay, the challenges faced by, sorry about that. So machine learning with edge impulse. So this is something very interesting. So I strongly encourage my student to try this. Yeah. So wide sensor support, data collection, custom integration based on the Arduino framework, the support of the ESP32, flexible deployment, multiple sensor application, community resources. So the challenges faced by the IoT module, cohort variability. I have students from mechatronics background, I have students from mechanical background, so they are not educated to the same level because mechatronics students are good in programming and they have more exposure to the electronics. Yeah, but you know, so that's the challenge. So I have to give them a lot of guidance, yeah, step by step, how to implement each thing, so that they won't, they will have not a problem. They will not have problem for mechanical student. ESP32 reliability, yeah, ESP32 because of the quality, they are not really reliable. If you, you know, if you get some hardware from not a very good resources. Time constraint, often juggle with multiple projects while they're doing this module. Complex integration, yeah, can be challenging for some students. Resource availability limited to necessary component may impede the project process. Yeah, technical support, data management challenges. Okay. Key area of IoT resource. So just for some understanding, edge computing enhance real-time decision making by processing data near its sources. So these are current IoT research challenges. AI and machine learning optimize performance and reduce downtime through predictive maintenance and anomaly detection. Advanced sensor technology facilitate precision data collection and real-time communication with 3G network, 5G network. Digital twin enable predictive maintenance and optimization. So you build a virtual model, you don't just throw it away. So this gives you opportunity, yeah, to actually build a connection between your virtual model and real system. And then you benefit each other because you can send the data to the model can detect any problem and then send it back to you. And the data can be collected and improve your model. Yeah. Cyber security, protect the industrial network with robust security measure to ensure data integrity. And then sustainability initiatives support resource optimization, waste reduction. So this is all these are frames benefit of IoT. So you want to find more use cases, more reason, yeah, to invest money in Internet of Things. So that is the end of my talk. Okay, so let's go back to the room.
Okay, thank you,
Thank
Mr.
you very much for listening.
Okay, thank you, Dr. Seng Chang. Can you hear me?
Yes.
Okay, I am the moderator for today. Let me introduce myself. My name is Jajang, Dr. Seng Chang. You can call me Jajang, and I will deliver the question from the participant. And yeah, thank you again for the enlightening presentation. And we now have time for questions from the audience. I know, like, invite the participants who are present offline to ask their questions, and then followed by a participant who have joined in online platform.
Okay.
Okay. When called upon, please state your name and affiliation before asking a question. Thank you.
Any question is welcome. Yeah, hopefully you learn something.
Okay. Can committee help me to pass the microphone, please?
Okay.
Okay, there is a question, Dr. Sanchong, for you. It's from Mr. What? Not yet.
Good morning, Mr. Sang. Can you hear my
Yeah,
sound?
thank you. I can hear you.
Okay. Thank you for the opportunity. My name is Neo. I'm from Agricultural Technology Department, and now I am assigned to teach physics, especially in the course of electronics. Actually, we have a plan to teach the students in the Agricultural Technology Department about the IoT for the control process. So we use some modules like thermocouples and relays. However, they didn't have any previous competencies and experience for doing programming and maybe electrical things. So do you have any suggestions or maybe
you mean
so they can learn?
do they have any basic? Yeah, I think for example, our mechanical student, they do some basic electronics, but very basic one, and a bit of programming. So they are not very high level. So the student come to third year, I'm sure they will have some learning capability, so they can do some self-learning. So I think we just need to show them some very good examples step by step at the beginning. Then they get used to it, then they should be able to do it. Because choosing this kind of ESP32, there are plenty of example, and the program you will see is very short. It's good enough. So this example with short program, they can just initially they can just copy and paste, change something. After a while, they will get used to it. So with some guidance and encouragement, they should be able to do it. And for the connection, because we are dealing with 5 volt, it's not high voltage. So, and also lots of circuit diagram, you just need to show them how to connect 2, 3 sensors. Yeah, and then they will have confidence to carry on. It's not a problem. DC motor, just help them. Yeah.
Okay, I'll try it in the modules.
No problem at all.
For the suggestions.
Yeah. Thank you.
Okay, Mr. Is that fit your questions? Okay. Thank you. So another question maybe from another participant in offline, and we please in our online platform. If there is anyone to want to asking question for Dr. Seng Chong. Okay, anyone want to join in the maybe committee can jump into comment section in YouTube. Maybe there is a question there. Okay. Maybe question from Mrs. Mariana from Electrical Engineering Department.
Yeah.
Okay, thank you.
Thank you. Hello, Dr. Seng Chong.
Hi.
Allow me to introduce myself. My name is Mariana, but my close friend also call me Anna. So
Anna, hi.
I want to ask about the simulation and data acquisition from the real project. So from your perspective, which one better?
You mean the data collection?
Doing simulation, gather data from the simulation from the MATLAB, or directly from our real project for implemented for our student? Thank you.
Okay, MATLAB is data collected will be from the real system, yeah? It really depends. Okay, maybe I do not understand your question fully. We do everything, yeah. So, yeah.
I mean, which one that we have to do first? Does we have to teach our student to do
Okay.
that through the simulation from the MATLAB, or
Okay, we don't do the simulation at the beginning with MATLAB because that is quite high level already. Because student will not be capable of building a SimScape model in MATLAB. So we just use the ESP32, gather the data from ESP32. Like the guy who implement the robot, we MATLAB, Simulink, and Kapila Sim, which is the robotic simulation. It's very high level for the student. He spent a few months doing that. So they will not be capable in this module. So we do not want them to be, it's just too much for them. So we'll just gather the data from the ESP32, simple, and then because there are some good example how can pump to the IoT cloud. You can use the Arduino IoT cloud. There are other IoT cloud like ThinkSpeak. There are many different open source IoT cloud where you can use. So that's the most easy one for the student. Yeah.
Okay,
Hope
so
that answer your question. Yeah.
yes, of course. Thank you. So
Thank you. Thank you.
the things that we have to do first to introduce our student with the real project first, rather
Yeah,
than
yeah, yeah. Just do it. Yeah.
another simulation software.
All the things available online, and loads of example and loads of, my student look at the edge impulse using the machine learning. So that is for a project. So I'm thinking of maybe if I have a chance, I want to introduce that in my module as well. Yeah, that will be the higher level stuff. But there, when there's an example, we can just lead them. Yeah, once we've done it, we can just share the experience. Yeah. Okay, so
Thank you, Professor.
no problem at all. Thank you. Okay, I have a question from the chat. Okay, from Novi. Yeah, my question. Yeah, what is your view on the trend of AI adoption in IoT devices? What are the biggest challenges? What the trend? Okay, I can only give you a generic answer. Yeah, so of course, yeah, there are more and more AI adoption, machine learning in the IoT devices. Basically, AI is going to be everywhere, and definitely that is the direction we are moving into, because you can gather data and then you can, adopt the AI capability to help us. Yeah. So, what are the biggest challenges? That's a good question. Yeah. What are the challenges do you think? Um, when we don't develop AI, yeah, as an engineer, we just use AI. So when AI available, we use it. Okay. It's not going to stop us. So I don't think there will be a lot of challenges. We just need to start adopting them, and then the AI getting better, we can just use them. Yeah, we are not doing AI. We are not AI developer. Yeah, we are AI user. Yeah, so we integrate our system with the AI model. Yeah, so I don't think that is a big challenge. Yeah, we are slowly moving there. Yeah, just more and more. I hope that answered the question. Yeah, just like students are more using more and more AI stuff. Yeah, and to facilitate their learning. Yeah, because once the data is there, once things are connected, it's not a problem anymore. Okay.
Okay, thank you. Maybe another participant in the room want to asking some question. Okay, from one more question maybe from participant offline here. So Dr. Saint Chong, we have one more question from
Oh, no
the
problem. Welcome.
participants. Is that okay?
Yeah, definitely no problem.
Okay, thank you very much. Please state your name and affiliation, please, before you asking your questions. Okay. I think there is no question. There is no more question. Professor Seng Chong. Thank you very much. Well, we have now reached the conclusion section. From what Dr. Seng Chong has presented and subsequent in question and answer session. Now here are the key takeaways from his materials. And first, IIoT is enhanced learning experiences. Industrial Internet of Things, or IIoT, enables real-time data collection and analysis, providing students with interactive and immersive learning experiences. And it allows for simulation and hands-on training in various fields, including engineering and technology. And the second, industry-relevant skills development. Integrating IIoT into the curriculum prepares students for the future careers. Familiarity with IIoT technologies equips them with essential skills that are increasingly demanded by employers and industries such as manufacturing, logistics, and healthcare. And third, as research and innovation opportunities, IIoT creates avenues for research and innovation in educational settings. Students and faculty can engage in projects that explore how new technologies fostering a culture of creativity and problem solving. And in summary, IIoT holds a significant potential to transform education by enhancing learning experiences, developing industry relevant skills, and fostering collaboration between academia and industry. Okay. Yeah. Dr. Sanjang presentation has provided us all with valuable insights into the latest development in the field of IoT. Thank you very much, Dr. Sanjang.
Thank you very much. You make a
Please
good
give him
summary.
a big
You
round of
are
applause.
already,
Okay.
you are
Thank-
already an expert in IoT.
Okay. Thank you very much, Mr. Sanjang. Hope we
Thank you. Thank you. See you next time.
in
Thank
the
you. Hope to
next
see you
session.
again.
See you.
Okay.
Bye, Mr. Sanjang.
Bye. Bye.
Ladies and gentlemen, we will now take 90 minutes break for tray and lunch break. Scratch your leg and refuel. We have refreshment available from the organizer. Please ensure you return on time, as we will be starting again promptly. We still have 3 more sessions, and we don't want to miss any part of it. So, ladies and gentlemen, I hope you please enjoy your break and see you back here in 90 minutes at 1 o'clock. Okay, thank you. Sekarang waktunya untuk isoma Bapak Ibu, jadi dipersilahkan untuk peserta seminar pada hari ini untuk istirahat dan makan siang. Nanti kita akan kembali di sesi berikutnya. Kita masih punya 3 sesi, dimulai dari pukul 1 siang. Ya, terima kasih. Untuk sholat mungkin bisa di Masjid Al-Hadad ya. di sebelah kanan gedung akuntansi. Ya, selamat beristirahat.
Politeknik Negeri Pontianak merupakan salah satu perguruan tinggi vokasi yang ada di kota Pontianak. Politeknik Negeri Pontianak menempati area seluas 6,3 hektar di tengah kota Pontianak, Provinsi Kalimantan Barat. Politeknik Negeri Pontianak dulunya dikenal dengan nama Politeknik Universitas Tanjung Pura, yang pada awal berdirinya hanya memiliki 2 jurusan, yaitu Teknik Sipil dan Teknik Mesin. Politeknik Negeri Pontianak memiliki 8 jurusan dan 25 program studi di kampus utama dan 12 program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD di Kabupaten Kapuas Hulu dan program studi di luar kampus utama atau PSDKU di Kabupaten Sanggau dan Kabupaten Sukamara. Berikut ini 8 jurusan pilihan dan 25 program studi yang ditawarkan di kampus utama. Jurusan Teknik Sipil, jurusan Teknik Mesin, jurusan Teknik Elektro, jurusan Akuntansi, jurusan Administrasi Bisnis, jurusan Teknologi Pertanian, jurusan Ilmu Kelautan dan Perikanan, jurusan Teknik Arsitektur. Selain itu, Politeknik Negeri Pontianak mempunyai beberapa program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD, dan program studi di luar kampus utama atau PSDKU. Masing-masing program studi tersebut secara terus-menerus bersinergi dengan seluruh komunitas Politeknik Negeri Pontianak dalam rangka memberikan pelayanan maksimal kepada seluruh peserta didik, sehingga Politeknik Negeri Pontianak menjadi sistem pendidikan tinggi vokasi yang menekankan penguasaan dan pengembangan ilmu pengetahuan dan teknologi untuk mendukung era industrialisasi. Politeknik Negeri Pontianak memiliki komitmen penuh untuk senantiasa meningkatkan fasilitasnya demi mendukung penyelenggaraan pendidikan dan pengajaran yang unggul untuk para peserta didiknya. Untuk mengoptimalkan proses pembelajaran yang menitikberatkan pada penguasaan nilai praktik demi mendukung teori yang dipelajari, setiap jurusan di Politeknik Negeri Pontianak dilengkapi dengan fasilitas sarana dan prasarana berupa laboratorium dan bengkel yang dapat mendukung bidang ilmunya masing-masing. Mahasiswa Politeknik Negeri Pontianak akan menjalani hampir 60% dari masa studinya dengan praktikum di laboratorium ataupun bengkel untuk menerapkan ilmu dan mengembangkan keahlian mereka sebagai fokus utama dari konsep pendidikan atau keahlian. Itu, Politeknik Negeri Pontianak juga dilengkapi dengan berbagai fasilitas lainnya, seperti ruang kelas yang representatif, mahasiswa, bank, masjid, ruang rapat, gedung aula terpadu, dan Polnetmart. Politeknik Negeri Pontianak juga berperan aktif dalam penelitian dan pengabdian pada masyarakat. Berbagai kegiatan telah dilakukan, seperti pemberian pelatihan bagi masyarakat yang membutuhkan penerapan teknologi, pemberian bantuan alat, dan kegiatan-kegiatan lainnya. Sebagai lembaga yang memiliki komitmen tinggi untuk melakukan berbagai kerjasama dalam bentuk seminar menjalin kerjasama dengan beberapa perguruan tinggi, baik perguruan tinggi di dalam negeri dan di luar negeri, pihak pemerintah, perusahaan, dan industri, serta asosiasi. Politeknik Negeri Pontianak juga aktif dalam mengirim dan menerima mahasiswa magang dan pertukaran mahasiswa baik di dalam negeri maupun luar negeri. Mahasiswa-mahasiswi Politeknik Negeri Pontianak juga memiliki prestasi yang gemilang, baik prestasi di bidang akademik maupun non-akademik, di tingkat nasional dan internasional.
Kami menghasilkan lulusan yang disiplin, jujur, bertanggung jawab, dan siap berkontribusi bagi kemajuan bangsa dan negara. Politeknik Negeri Pontianak.
Tepat waktu, ukuran, dan aturan. Politeknik Negeri Pontianak merupakan salah satu perguruan tinggi vokasi yang ada di Kota Pontianak. Politeknik Negeri Pontianak menempati area seluas 6,3 hektar di tengah Kota Pontianak, Provinsi Kalimantan Barat. Politeknik Negeri Pontianak dulunya dikenal dengan nama Politeknik Universitas Tanjung Pura, yang pada
Distinguished ladies and gentlemen, hope you all had a refreshing break. And let's continue with our seminar agenda. And welcome to our main agenda. The seminar and discussion session will be handled by me as the moderator. And at this session, we cordially will meet with Professor Dr. Kamil Haddadi. Is the professor connected with us? Hello, good morning, Professor.
Hello, can you hear me?
Hello, Professor. Can you connect with us?
Yeah, can you hear me?
Can you hear me?
Yeah.
Professor Kamil?
Yeah, I can hear you. Can you hear me from your side?
Ah, okay. Okay, maybe we have some adjustment about the volume, Professor. So we will inform you later after the volume adjustment finished already.
Okay.
But can you hear me, Professor?
Yes.
Ah, okay, thank you. Hello, Professor. Can you say hello?
Hello, everyone. Can you hear me now?
Okay. Maybe we have some technical issue about the volume. Just hold a. Wait a minute. Pardon, sir.
Hello, check.
Hello.
Hello, Professor. Can I ask you to move
Yeah,
closer
hello.
the mic?
Hello, can you hear me?
Okay.
Hello?
Closer, maybe?
Yeah.
Because
Can
I
you hear
can hear you crystal clear from here.
Excuse me, say it again, please. Can you hear me?
Tolong tutup pintu hujan.
Check test.
Hello, everyone. Can you hear me?
I can hear you, Professor, but not crystal clear. So the problem is like can't hear more. We just make like an adjustment, like little bit adjustment for the volume. Sorry for the disturbance, sir.
No, no problem.
Okay, Professor, I think we going to start this session. And for me, this afternoon, we move on to our third keynote speaker session. Joining us via Zoom meeting is with us here, Professor Dr. Kamel Haddadi. Good morning, sir.
Good morning. Kamel.
Can you hear me?
Yeah.
Okay, excellent. I can hear you, but not clear, but it's okay. And we are delighted to you could join us as speaker in this international seminar. Professor Kamal, with your permission, I would like to share a brief overview of your distinguished background and accomplishment with our participant. Professor Kamal Haddadi, a full professor at the Institute of Electronics, Microelectronics and Nanotechnology in University of Lille and CNRS, leads the lab Space RF2S with MSc and PhD degrees from the University of Lille. His research focuses on developing advanced microwave and millimeter wave instrumentation, especially for non-destructive testing. Professor Haddadi's groundbreaking work has led to approximately 150 publications in prestigious journals and conference proceedings. Recognizing for his expertise, Professor Haddadi serves on several international committees, including IEEE, MTT, RF nanotechnology, and IEEE, MTT 24 microwave millimeter wave radar sensing and array system. And he is also a technical program committee member for various IEEE conference and contributes as an associate editor for IEEE transactions on instrumentation and measurement and IET measurement science and technology. And we are truly honored to have such an esteemed expert in the field of microwave and millimeter wave technology joining us today. In today's seminar, we will be discussing on innovative IoT sensor development for non-destructive testing and biomedical application, from design to AI-driven modeling. Professor, you have approximately 25 minutes for your presentation, which will be followed by 20 minutes question and answer session. And Professor Haddadi, are you ready for your presentation?
Yes.
Okay.
Can you
All
see
right,
my
Professor.
screen?
The screen is yours.
Okay, so first, thank you very much for this introduction and for this invitation. Good morning or good afternoon, everyone. Salam alaikum. So my name is Kamel Haddadi. I'm coming from the University of Lille in France. Just before beginning the presentation, so please tell me if you can hear me well. Can you hear me?
Yes, sir.
Okay, thank you. So let's begin by giving the general context of this work. So I'm coming from Lille. So just before, so we can localize Lille, which is in the very north of France, which is the fifth largest city in France, and which is 30 minutes from Brussels, 1 hour from Paris, and only 1 hour and 25 minutes from London. You have here a picture of the city center of Lille. We welcome, of course, some students from abroad, and we have here some pictures of our dormitories. Our University of Lille was first the Faculty of Science, and it was in fact created by Louis Pasteur, who has discovered the microbiology and who was the first dean of our university in 1896. In 2018, so we have merged our three universities, which were called Lille 1, 2, and 3, and which concerns 6 domains, going from arts to science and technology. So we have 3 universities at different locations around Lille. So just to have in mind that this is the biggest university in France with 80,000 students, 66 research labs, and 350 PhD theses, which are defended each year. We have here a map of our university in Lille 1, which is built around the central library. And in particular, so I am a teacher at the Institute of Technology, which concerns mostly undergraduate students, and we have 7 departments: business, biology, microbiology, IT, mechanical engineering, chemistry, and electrical engineering. You can see here the buildings, and it concerns about 2,130 students each year. And in particular for the electrical engineering, this is just one example of what we are doing in the first year of this study, semester 1 and semester 2. So we learn energy, digital electronics, computing, electronic systems, and as we will see later, a big part will be devoted to the project. We have here some pictures so taken. We have conventional classroom. We have a lot of practical work, which is, from my point of view, the most important to learn. So our diploma is a 3-year program, and we have in fact less teaching and more training. The total represents around 2,000 hours for the 3 years. And we have also more professionalization. So it means that our students, they have to do 26-week internships during these 3 years. And as I said before, so we are trying to have less theoretical lessons to implement them through the project, to have a student-centered project and with real industrial application and innovation. As I am also a researcher, so the main idea is to bring also my research into education and to make the link between education, research, and industrial application. So our mission is definitively to merge education, research, and innovation. My background is about radio frequency systems, in particular RF communication from 5G to 6G, something which is still supported in our lab. And this is important to have it in mind because this is mainly this telecommunication, which is driving actually the electronic sectors. I won't go into publication for this presentation. And for my students, so I bring this, what we call the microwave techniques, and we will have some application. So just before beginning, so what is microwave? Microwave is a quantum of electromagnetics, which is called a photon, and which carries very low energy thanks to the this formula. So microwaves, in comparison with gamma radiation, are electromagnetic waves, but which have very low energy, and that they can be used for some particular implication because they are non-ionizing, they have no thermal effects, and microwave, they penetrate into non-metallic materials, what we call dielectric materials. So we can use them for sensing, for IoT sensing, to have some information. We can send a wave through materials, the wave will be reflected back, we can analyze this wave and to have some information in a non-destructive manner. And so this will be some example of what we do. So we develop a full instrumentation. And the nice thing of this topic is that we have different things. We have electronics with the measurement systems. We have some props with some mechanical engineering. We have to position some measuring probes onto device on the test. We would like to do that using robotic systems. And then in this kind of project, we can show to the students that all of the topics are merged together. We said differently, electronics and automatic, they can live together because we have here a single application instead of studying all the things together. And for example, what I do with my student, we want to use some props, which has very small dimensions, 0.1 millimeters, as we can see here. And if we want to get good results, we have to put the probe on device on the test, and we have to align perfectly the 3 fingers of the probes onto a device on the test. And this is very difficult to do it manually. And then we develop a fully nano-robotic systems using artificial intelligence. This is the main different item that the student needs to address during their courses. And at the end, we have a system which has been completely built with my students, which comprise electronic systems, a mechanical part, and some nano-robotic probing station. What you can see in this video is the probe who is landing on a device on the test, and this is done using artificial intelligence module from a well-known software which is called LabVIEW. And the main idea is to avoid to have one operator who is going to probe manually the probe onto the device on the test, and then we can get very good results. So I address also macro non-destructive testing, as we said before. So first, what is the interest for using microwaves radiation instead of optics or instead of gamma rays? As said before, this is low power, non-ionizing, it has high sensitivity, and it can work in a non-contact manner. But there are some disadvantages. In order to address some commercial solution, is that the instrumentation is oversized in terms of size, weight, operation possibilities. It requires an expertise for the calibration. And then our goal is to develop some new sensing and services outside the laboratory environment. And we can do that with students because they can learn electronics, and then they can design, fabricate some very low-cost system which have the same performance than actual system which are oversized. We have here some examples in different technologies. I'm not sure that everyone is expert in microwaves, but there are different technologies. This one is called waveguide. So this is a system which has been developed for radar application to measure distance to a target. It can be done also using some conventional PCB and using a clean room, or it can be, we work also with some very big electronics company. This is ST Microelectronics, and then we can develop a large panel, a large family of different technology. And this is very interesting also for industrial application. One example, so this is a system that has been developed by my students. This is a radar system which operates at 2.45 gigahertz, and this system is connected to one antenna, and we address one application, which is the monitoring of water content of the humidity in concrete. And then we just position the antenna at a certain distance from the concrete materials, and then with the system we can record the reflected wave, and from this reflected wave, after some modeling, you can see that we can, so the measurement is done during 16 days, and from this very heavy mathematical modeling, we can determine the moisture content which is in the concrete materials. As we can see here, so this analytical model is a little bit complicated, and now we are shifting to artificial intelligence. And this is one other example of what we can do with artificial intelligence. We can identify and classify different types of building materials in a non-contact and non-destructive manners. So we did that using the same radar systems, and main contribution from the student was to design a compact and low power radar system instrumentation to create original data sets, so to get some results, to ensure also the measurement reproducibility that can affect the performance. This is very important, and to develop some machine learning models for the recognition, classification of planar building materials. Then obviously we have a very big measurement component for data accumulation. So we measure what we call the S11, which is the reflection coefficient from different building at different distance to have enough data. And we consider also samples which have different thicknesses. We can see here some example of the common building materials coming from metals, wood, glass, and so on. And we create a very big data set. And then we just use the conventional learning classification model. So we use 30% of this measurement data for testing the data set, and 70% are used to train the machine learning algorithm. And for the outputs, the first step of this study was to identify between different materials. Okay. And obviously we get a lot of results, and it's very important for the student not to use directly artificial intelligence, but it's very important to select the quantity of interest. For example, here we have a lot of measurement, and they just from the radar data, so they selected, for example, only two frequency, the amplitude and phase shift, in order to have the best parameters for their machine learning algorithm, and to avoid any heavy computation. So we use then the model, the algorithm are implemented using a Python library, which is freely available, and we tested two algorithm, SVM and DCT, with this related accuracy. With some other students, what we do, we use also this radar for to, as I said before, to have some new societal application. We can use a radar system. So I'm sorry, this is in French. This is done by this team of students. We can use a radar system to sense the mechanical movement of the chest. And from this, we can measure in a non-contact manner the cardiac and respiratory frequencies. And there's some very interesting application. And I think one of the potential one is to monitor elderly people without any contact. And then in this kind of application, we can measure some physiological parameters. And I asked the student to design and to build a very low-cost systems with an apps with one application, and they succeed on that. We develop also a contact biomedical IoT platform. So I was very happy because this project was started in 2017, and I work with some students from your institution, and the Ryan Renaldi, who come from Indonesia, and who did the first internship to work on this biomedical IoT platform. And then in 2019, I had 3 other students who have continued this work. The main idea was to develop a platform to monitor the temperature, the cardiac frequency, respiratory frequency as a function of time, but with very high measurement accuracy, because this is very difficult to get the cardiac signatures, for example, when you are sitting, for example. But they did a good work. And thanks to this work, so we had a project which has been fully funded, a national project by the Ministry of Transportation, with the main idea is to use this platform developed by the students, temperature, respiratory rate, and heat rate, and to connect it to driving simulator tools. With the main idea is to, with the main idea was, sorry, the main idea was to monitor the cardiac and frequencies when we have a driver who is driving, and to have some data between physiological parameters and driving data, in order to understand mainly the accident. As we can see here the cardiac signature, respiratory rate, the temperature when the driver is testing the system. One other application that I have started with my project last year was about potato. In our region, we have a lot of potatoes, and if you don't know, we need to stock the potato at low temperature between 2 and 4 degrees. But in this case, they induce some sugar at low temperature, so the potato, so they induce some sugar inside the potato, and we need to avoid that. And so there was a real demand, industrial demand, to develop a system which can sense the sugar content inside the potato, but in a non-contact manner, because potato are living systems. So with my students, so we use an existing dielectric pop kit. The system is used to send some waves into materials and to have some information about the absorption. It's like the same system as the microwave oven. There is some absorption in the liquid materials, or material which have some liquids, and they absorb the material, and then we can have some information about the content. And then this is very interesting for the student, because they learn a lot, because this is a typically application of electronics, but for other applications than conventional electronic systems. So, and then we did a lot of tests using some probing, using some different potato, and to make the link. And this is one ongoing works. And again, thanks to the work of the student, this is now a fully funded project. We develop also some measurement technique to go at a lower scale. So what I mean, there is a very big demand to characterize some materials, to detect some defect inside some materials, but with very good spatial resolution. And then we use a very small probes, and then we put the probes in the vicinity of materials. We can move the probe, or we can move the material under the probes, and then we can do some images. And again, so this was has to be fully automated. So then for the students, what we do is that there is an electronic part, automation part, robotics parts, and then at the end, they develop a fully systems which can be used for imaging some structures. We have, for example, here 2 nice images of an image which is a ring pattern, which has a dimension which is very small, 400 micrometers. And this feature has been processed into silicon at 20 micrometer depth, and it has been recovered by a thick resin, 30 micrometers. And then the structure is buried. If you use some optics, some conventional optical microscope, you cannot see anything. But if you use a microwave probes and you move it, and then we can detect perfectly the ring pattern. And you have two information. I won't go in details, but you have amplitude and phase shift, and then we can correlate the two together. We do also something which is nano, at the nanoscale. Nanotechnology is now everywhere, and this is very important for the students to learn about this this nanotechnology and how can we see the nano world. And then in this case, we combine two techniques. The one which is well known, which is called atomic force microscopy, which is used to detect the, the profile, the mechanical profile of nanoscale features, and radar application. And they build what we call the nano radar system. This is a picture of the nano radar. This is a very complicated piece of equipment, but still interesting for the students. And typically, I won't go in details, but we can see features that can be much smaller than, let's see, 100 nanometers. And we develop also our own system, which is a very complicated piece of equipment. And with still some electronic parts, some nanobotic stages, with the main idea is to see a probe at the nanoscale, which is imaging some features. In fact, this is an atomic force microscope which has been built inside what we call a scanning electron microscope. And this is very interesting for the students because there is a robotic part and they have to automate everything. And at the end, they can create a system, which is quite interesting for them. Very recently, so we have a project which is about shieldings, how to shield materials. Some electromagnetic waves are going everywhere, and sometimes we don't have we have to avoid this electromagnetic waves, so we have to shield the materials. And in this case, we need to use metallic part or conductive part because electromagnetic wave don't penetrate through metallic materials. And this was also a fully funded project, which will be ended next year, and with different partners from Germany, from Serbia, and Slovenia. And then we have to develop some samples. And the simplest idea is to look at the existing solution. We have some standard methods, which is a vector net localizer, which is connected to what we call the coaxial test samples, which is a transmission measurement. We put the materials in between, and then we send a wave, and we can see what is reflected back, what is transmitted, and we can, from that, we can determine the shielding efficiency. This is actually the commercial solution, which is called ESTM, and we didn't buy this solution. So first I asked the student, you have to take the dimension of that, and then you have to design it using some software to do some electromagnetic simulation. This is what they did. And at the end, so they arrived and told me that the system can work only up to 6 gigahertz. And this is mainly due to some part that they have identified. And then from that, we have decided together to develop our own system. So they just use also the electromagnetic simulator. We designed a very simple setup using some coaxial cables, some metallic part. This is what we can see on the simulation. And yeah, this is what they developed. You see, this is a measurement system to cables and just to coaxial cables to metallic plate, and they put the material to be tested in between, and then we have get very good results. And this is typically an example of material that has been developed by our partner, which is reduced graphene oxide with silver nanoparticle. I won't go in details, but we developed some very specific materials. And then with this technique developed by the students, so we can quantify the shielding efficiency. We can see that 70% of the wave is reflected by the materials and only 1% is transmitted, meaning that the other part is absorbed by the materials. And this is still an ongoing work, and I would like to thank you for your attention.
Dear ladies and gentlemen, please give a big round of applause for Professor Haddadi. Okay, thank you, Professor Haddadi, for that enlightening presentation. And we now have a time for question from the audience. And now I invite the participant to ask their questions. When called upon, please state your name and affiliation before asking your questions. And so the participant can ask the question in online or offline. So in online would be in Zoom meeting platform and YouTube platform. Maybe anyone in this room want to ask some questions for Professor Haddadi? Okay. The committee, please can have pass the microphone.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. I want to ask some question. Can Indonesia make their own chip industrial with nanotechnology, and what is the biggest problem on build our own industry? And thank you. That is the question.
Okay.
Oh yeah. I forgot to mention what my name. So my name is Badli Firmansyah. I'm from electrical engineering.
Okay, thank you, Mr. Firmansyah. And it's quite crystal clear for you, Professor, the question. Or should I the question?
Yeah, it's quite clear. So thank you for your question.
Okay.
Alaikum salam. This is a good question. So the first part of the question is, can you build your own systems for nanotechnology application? If I completely understand, and I would like to say yes, and because there is a very big need from the industry to develop some systems for nanoscale characterization for electronics, but which are low cost. Most of the system that has been used for nanotechnology characterization has been very big equipments, which has been only been in the lab, in very big laboratories. And now we had a project on that, and there is a big need to develop some systems which are low cost and which can be used for nanoscale characterization. And now we have some very low cost components that you can buy, and then you can build definitively your own systems from hardware point of view. And you can also use some very low cost systems for, let's say, like the Arduino. I think you know what is an Arduino board, and we can use that to control everything. Does it respond to your question?
Yes, thank you.
Okay, thank you, Mr. Firmansyah. And anyone want to ask a question for Professor Haddadi? Maybe we can check. Okay. Thank you. Can Kamari pass the microphone for?
Thank you.
Yeah. Thank you.
Good afternoon, Mr. Kamal Haddadi. I am Nanda from electrical engineering. So what I want to ask is, for the microwave or the nanotechnology implementation to human, is there any further study about what the effect for our condition if we are affect from the microwave effect to the body? And then the other one is for the AI implementation. For the biomedical, is there any ethical issues or ethical agreement if we use the human as the objects of the research? Yeah, is there any politics, maybe not a political, but policy in your country that allow that to make a further research? Thank you.
Thank you very much for your two questions. About the ethical research, obviously there is some laws, especially for the European Commission, especially about the data. We cannot bring the data from anybody about this medical. So, but we can involve the medical staff. If we involve the medical staff, and if we have the agreement from every persons, it should be in an anonymous way, of course. Then we can do that. But we have to do it carefully, thanks to the European regulation. Again, to imply some medical staff to have an agreement, and all must be anonymous. And then in this case, we can work. And so this is for the second question. And the first question, sorry, was about the first question.
The last questions.
The first one, right?
Yeah.
Is there any further study? I mean, if we for the human body condition, if we are affected by the microwave or nanotechnology?
Yeah. This is definitively a very nice question from my point of view. There is one agency in France, a national agency, and most in every country, and they are trying to work on the effects of microwave radiation on human body. And they just do some bibliographic analysis, and at the end there is no clear conclusion. They just said there can be some possible effects of the microwave radiation on the body, but this is not really proven. From what I know, is that the wave that we are using in our application are typically very low power. For example, if you use Wi-Fi at home is 100 milliwatts of power. We are using 1,000 times less power than Wi-Fi for our application. This is very low power application. There is no effects. There is some thermal effects, but which is very limited, though I'm pretty sure of that. And to study the biomedical effects of microwave radiation on the body. In fact, I have a very big collaboration with University California Irvine in US, and we developed the systems to study locally microwave radiation into a single living cell. This is the only way to see the impact. You have to consider a single cell. We are working with the Hospital for Infants in Philadelphia, with University California Irvine in 1 hour from Los Angeles. And then we develop all of this stuff. We have now some very good results, and we can now understand the effects of microwave into a single cell. So we have still some works to do, because this is very, let's say, complicated to have a clear conclusion about this. And so we need to perform some additional works, but this is on the way. But this is definitively a very good question. Effect of microwave on human body, actually no one knows, I would say. But there are some ongoing studies. Thank you very much.
Thank you very much for your answer. So if I can conclude your answer is if we want to research more further about this, so we have to engage the medical people, yeah, for this one.
Yeah, if it depends. For example, for the application for which we have the biomedical sensor with the drivers, and we check their cardiac frequency, respiratory frequency, it's always good to have a doctor. You don't have to engage all of the medical staff from the hospital, but you have a doctor which will be here, because this is very important. In our application, the main idea of this funded project is to understand the accident of the drivers. And it depends also on the drivers. Some drivers are taking some medicine, some other are orders. So it's always interesting to have some doctors involved.
Thank you. Thank you.
Thank you.
Okay, thank you, Mrs. Nanda, for the question, and thank you, Professor Haddadi. Okay, advertisement. We would like to invite another participant to join us in the question and answer
session. Another question maybe from, oh, okay. Kind of, my committee, yeah, okay, thank you.
Uh, good afternoon, sir. My name is Hafiz Putra Pratama, and I'm from alumni from Politeknik Negeri Pontianak. I want to ask based on the presentation you given about the project you displayed. What are the sorry? Is the project is still being developed or have already gone to production? Thank you, sir.
Sorry, can you repeat? Maybe the professor cannot hear you crystal clear. Ulangi.
Sorry, the question is about the project you display on the presentation is they into the develop stage or into the production. Okay.
Thank you for this question. So indeed, some of the projects that have been presented are under patented, and this is very important also for the student. You know, us as a professor, I cannot create, for example, my company. I cannot create my startup company. It's strictly forbidden in France to have a public employment and to have also a company. And what we are trying to do is to encourage our students to create their startup companies. And so in this frame, mostly, actually, for example, for the potato, what we have developed, and I have one student who is working on that, and we are trying to push him because there is a lot of helps for our government to create a startup company. This is definitively what we are trying to do, is to develop some application with high societal and economic impact. And I would like to say, yeah, when you have a concept which is validated, we are trying to push our students to create their company. Not myself, the students. Is that clear?
Thank you, sir.
Okay, thank you, Mr. Hafiz. And thanks to Professor Haddadi for the answer. And then we still open the question and answer session. And maybe we have, oh no, okay. We have another question. We have another participant who want to ask question maybe. Let's check on the comment section on the YouTube or Zoom meeting. There's no. Okay. Okay, if there is no question, okay. Okay, Professor, I think it's no more question, and then we have now reached the conclusion section. From what Professor Haddadi has presented and the subsequent Q&A session, here are the underline or resume from his material. Okay, innovative IoT sensor solutions are very crucial for advancing safety and efficiency in both industrial and healthcare setting, and especially it's very important for our with correlation with our topic today, smart education in the digital era, integrating IoT and AI for enhanced learning experiences. So yeah, it's really important for us to know about innovative IoT sensor solution and how to manage with NDT. Yes, Professor? Okay. Thank you. Maybe that's all for me. That's all for me. And then maybe Professor Haddadi want to say one or two words for us.
Yeah. So first, thank you again for this invitation. It's always a pleasure to have an exchange with you. Thank you also for the very pertinent questions from the audience. This is very appreciated also. And I would like to say that we have still some MOU with Polytechnic, and so I invite obviously all students which are interested to join us for internship in our labs and for maybe also for some lectures. We have regularly some students all along the year. Actually, I have people from Europe, of course, but also some Japanese students. So if you are interested to join us for an internship, you are more than welcome to integrate our lab. So please don't hesitate to come to Lille, to come to France. Thank you.
Okay, thank you, Professor. It's very big opportunity for us to maybe to join the professor in French, maybe. Thank you very much, Professor. And Professor presentation has provided us all with valuable insights into the latest development in the field of IoT sensor development for non-destructive testing and biomedical applications. Once again, thank you, Professor Haddadi, for your significant contribution to this seminar. Let's give a round of applause for Professor Haddadi. Okay, thank you, Professor.
Thank you very much. Thank you.
Dear ladies and gentlemen, I'm still your moderator for the next session. Actually, with the fourth case speaker, and we will meet with Professor Dr. Thomas Kohler. Is the professor with us? Oh yeah. Okay. So, dear ladies and gentlemen, from first speaker, the second speaker, third speaker, and we have two more speakers left. And according to every speaker, it's really interesting that we know the development of IoT and AI, especially to enhance our learning experience, is very significant. As we know, and past years, we know that we don't have any AI or IoT developed, and we just know about Microsoft Word and the others. And I'm in my as my experience in my teaching practice, I usually use Grammarly as a grammar for checking my grammar AI. So it's really helped me for teaching and make my thesis proposal. And when I try to paraphrase the journal article, I use Quillbot. So it really helped me a lot. We can imagine that at the 2000 eras that they don't have Grammarly, Quillbot, or maybe Mendeley for the citation and so on. And before we go to the next speaker, maybe there is a question for this event, or maybe for committee. Okay, we will have a break for around like 15 minutes. Oh no? Oh, 5 minutes. Okay. We have 5 minutes for coffee break. So, ladies and gentlemen, if please enjoy the drink and snack in outside. Thank you.
Yang ditawarkan di kampus utama. Jurusan Teknik Sipil, jurusan Teknik Mesin, jurusan Teknik Elektro, jurusan Akuntansi, jurusan Administrasi Bisnis, jurusan Teknologi Pertanian, jurusan Ilmu Kelautan dan Perikanan, jurusan Teknik Arsitektur. Selain itu, Politeknik Negeri Pontianak mempunyai beberapa program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD, dan program studi di luar kampus utama atau PSDKU. Masing-masing program studi tersebut secara terus-menerus bersinergi dengan seluruh komunitas Politeknik Negeri Pontianak dalam rangka memberikan pelayanan maksimal kepada seluruh peserta didik sehingga Politeknik Negeri Pontianak menjadi sistem pendidikan tinggi vokasi yang menekankan penguasaan dan pengembangan ilmu pengetahuan dan teknologi untuk mendukung era industrialisasi. Politeknik Negeri Pontianak memiliki komitmen penuh untuk senantiasa meningkatkan fasilitasnya demi mendukung penyelenggaraan pendidikan dan pengajaran yang unggul untuk para peserta didiknya. Untuk mengoptimalkan proses pembelajaran yang menitikberatkan pada penguasaan nilai praktik demi mendukung teori yang dipelajari, setiap jurusan di Politeknik Negeri Pontianak dilengkapi dengan fasilitas sarana dan prasarana berupa laboratorium dan bengkel yang dapat mendukung bidang ilmunya masing-masing. Mahasiswa Politeknik Negeri Pontianak akan menjalani hampir 60% dari masa studinya dengan praktikum di laboratorium ataupun bengkel untuk menerapkan ilmu dan mengembangkan keahlian mereka sebagai fokus utama dari konsep pendidikan vokasi atau keahlian. Selain itu, Politeknik Negeri Pontianak juga dilengkapi dengan berbagai fasilitas lainnya seperti ruang kelas yang representatif, internet nirkabel, perpustakaan, poliklinik, lapangan olahraga, asrama mahasiswa, bank, masjid, ruang rapat, gedung aula terpadu, dan Polnetmart. Politeknik Negeri Pontianak juga berperan aktif
Ladies and gentlemen, we cordially invite you to have a nice seat and back to your position because in a few minutes this session will proceed in no time. Thank you. Before that, I would like to say good afternoon, Professor Kohler. Can you hear me?
Good afternoon. Yes, perfect.
Okay.
Thank you.
So, my name is Jajang Nuralam and I'll be your moderator for today.
Before that, let me introducing your profile first to the attendees. And now it's my pleasure to introduce our fourth keynote speaker, Professor Dr. Thomas Kohler. Professor Dr. Thomas Kohler is a prominent academic in the field of engineering and computer science at Technische Universität Dresden, TU Dresden, Germany, with a strong background in systems engineering and information technology. He has made significant contribution to research and development in software engineering and distributed systems. Professor Dr. Kohler is a recognized leader in engineering and computer science, contributing significantly to both academia and industry. And Professor, you have 20, sorry? Professor Kohler, you have approximately 25 minutes for your presentation, which will be followed by 20 minutes question and answer session. Okay, without further ado, Professor Dr. Thomas Kohler to deliver the material. Please give him a warm round of applause. Okay, the screen is yours. Thank you.
Thank you very much for the very kind introduction, and I directly jump into my presentation, just sharing my screen, and in order to start with the talk today. Okay, so now my screen is fine. Yes, thank you for inviting to join the conference on Smart Education and Digital Age of the Electrical Engineering Department of Pontianak University. Thank you especially to Professor Adimawan for connecting and collaborating since a long time in a very responsible way. I will talk about AI and openness and trying to link the developments in the context of digital transformation with demands on skill or talent development and continuing education or higher education patterns. So let me start first with the structure of the presentation. I will start with the background, my background in teaching and research and in transfer, because I think it's quite useful to understand how the research, innovation and education system is arranged in the context of our University of Technology here in Dresden, Germany. Then I will have a focus on the future of work, how digital transformation and future skills are interrelated. And in the next step, I will come to some conclusions for the talent management in the tech sector, which is meaningful for vocational and as well other, of course, areas of technology skills. And of course, as you did invite already, there will be discussion afterwards, and I'm ready and for promising discussion within the participants of the conference. So let me start with the first step. TU Dresden, where I come from, is a German University of Technology. It's a typical University of Technology because it has a strong focus in engineering in very different fields. We have even 2 schools of engineering, but on the other hand, we are as well a full university, meaning that we have a profile that combines engineering education with other segments of education. So besides engineering education, is as well medicine or social sciences, even humanities or legal studies, and embedded into that as well teacher training and vocational teacher training. So it means that the teacher training is taking place with a mandatory 5-year program for teachers to become in Germany in this education, in this technology context. And what perhaps coins the specific character of activity in research and as well in education is that the technology-driven or design-driven approach calls for bringing together analytical perspectives and as well innovation and design-based activities. So usually engineers, but even our pedagogues intend to build something. So to understand and then as well to construct kind of a future. And at that university, we are running a large institute for vocational education, vocational teacher training. And those students here study 5 years in very different subjects to become teachers in areas of vocational education. Of course, we train as well teachers in general education and social pedagogy, but my focus is, of course, vocational education. And the chairs that you can see here by number are the largest compilation in any German university. We're having 12 different chairs. 5 to 6 are focusing on the special didactics, and the other half is focusing on more overarching aspects. And if we talk about special didactics, then the teacher training is based upon the differentiation of sectoral focuses. For example, there is a chair for social pedagogy. There's another chair for well, the technical domains like automotive, information science, and electronics industries. There is a next chair that deals with household-related economics, and another one that deals with the well, the service sectors and so on. So we have different vocations in different industries, and for training those vocations, we educate teachers that then will support or build the backbone for the vocational schools. And usually a teacher here would have 2 subjects, would be trained in 2 subjects. One would be a vocational subject and the other one would be a rather general subject. This is how our system is designed, and the Institute delivers research and insight in education and in didactics, and the knowledge about, let's say, chemistry or electronics or a medical profession, a very specific knowledge, then comes from the other faculty of medicine or the faculty of engineering and so on. Now, this is one background. The next background is my specific chair. I'm a professor for educational technology at the intersection between social sciences and I would say rather well, computer sciences or media development. And this, by the way, you may use QR codes to scan it, and you find an English website behind. And this research and profile is embedded into teacher training, but as well in other activities like international research cooperations and as well training measures for colleagues and in cooperation with colleagues in very different countries of the globe, with a good focus on South and Southeast Asia since quite some years. Continuing with this, we as well have research facilities like the Center for Open Digital Innovation and Participation, where I'm working as a director. And this center is not so much focusing on the well, development of specific skills when it comes to the implementation of new digital technologies into any kind of industrial sector. It is as well considering that the workflow and the working processes are changing if we implement new technology. So transformation is taking place through or due to new production technologies. This as well applies to education or any knowledge sector. For example, if we, let's say, transfer the classroom into a Zoom facility like we do today, then we need to have different, of course, different skills. But we need to have as well different infrastructures, and we come to a different production workflow. That means that as well the management and the design of the production of knowledge is going to be shifted. And this type of understanding is well researched and as well implemented in very many measures by this Central Research Unit of TU Dresden University of Technology. On the other hand, we are as well trying to transfer as good as possible the understanding and the insights of our university within several transfer institutes, and one of those is the Institute for Further and Continuing Education. And just these days we are having a group of 25 ISMA awardees from Indonesian higher education institutes in our place. We are quite happy that those have arrived, and they are studying with us for 1 semester in a special program for that group, but as well bringing them together with other students from Germany and from other international places. And it's quite a pleasure to have continuously colleagues from Indonesia here, as other measures that focus rather on the skill development of teaching staff or for upskilling engineering colleagues, and sometimes we have a focus even on junior students from very different places. But there's a strong focus, a strong attention given to the partnership with the Indonesian institutions since quite some years. Not too much detail here. I'd like to continue with the very topic. So our research is going to be implemented and developed in an open and cooperative way with partners globally, and usually the result or the findings may be developed further through conferencing, and then peer-reviewed proceedings may be an interesting component as well, or element to share insights with focusing on vocational education, on regional and development, on smart societies, and as well community development as a specific research topics. In case you are interested, you find most of those publications freely accessible via ResearchGate on my page, or just may ask. Now let me come to the very focus of today's talk. This is how digital transformation and the future of skills is interconnected, and I like to reflect about the future of work when it comes to implementing AI and rather digitized type of elements into working process. What we can observe at this point in time, and I would say even since a generation, is that the digitalization of production is taking place in all sectors, in all industries, social sector industries, tourism industries, but as well nutrition or agriculture industries, and of course foremost in the classic engineering sectors. And what it means is that the production of physical or natural goods goes along with the production of data. So we have our smart devices, we have our sensors, we have our databases, and always when we deal with any kind of product, not only with the intangible products, but as well with the physical products, there is kind of data configurations that are a part of the production process. And those data by itself may be considered as another type of product, which can be treated then independently of a location, or treated with different skills and different infrastructures by workforce and by automated systems, even worldwide. So if we produce, let's say, a car at a certain location, then we as well will have a number of softwares and digital components that may be configured at any place around the globe, or may be maintained even after this physical device has been completed and is already running, regardless of location. And it may as well be processed or used instantly, so ad hoc in a very recent way. And usually those processes of data management and data processing and working with those products are not only done by humans with a special education, like computer technicians or media specialists. No, those processes are as well implemented by machines or by automated systems. And I would call them as well digital assistants. So now we have a big hype around ChatGPT and AI. On the other hand, we have those digital assistants implemented since quite some years in very many different technologies, and those technologies are working rather independently of humans. They support our activity, they support our everyday routines, and they support, of course, processing data in context of almost any well, more or less technical product. So the localization of the work is somehow disappearing when it comes to digitization. And as well, the skills that are going to be implemented through different vocations, for example, and as a consequence of proper training in a Polytechnic or in a vocational school or in a university, those skills are as well supported by machines or technical components that are trained differently and that have learned to support us in a good way. On the one hand. On the other hand, we can as well observe that the production itself is changing, and that we involve as well the consumers into kind of production process in very many sectors. So we talk about the new concepts like co-creation, for example. We may talk about patients in the medical sector. We may talk about learners in our education sectors. We may talk about the regular citizens who just somehow support dealing with the information in a or with the production in a way when they become part of a production process by delivering their data or by co-creating the very product. And then we come to new types of well, cooperation, and we call it a prosumption. And then those co-producers are somehow becoming prosumers. That shifts, on the other hand, the location of our production activity into different places. So it's not a factory anymore or the workshop anymore, which solely serves as a production site. It's as well the home or any other place that becomes the production location. And this co-creation or co-production may be arranged over a chain of different businesses in a principle of co-opetition. And what is interesting here is the question that is as well meaningful for us as educationalists: who is responsible and who has the capability to design this new production place, which is, with my smartphone in my hand, rather and the apps I'm using, a place that is outside a classic factory, and it's rather at home, or it's somehow networked with other production sites. And the very question then is who will be responsible, or who does have the skill and capacity to equip those production sites, and how to prepare the individual user for being part of such a co-production process. I think there's a strong need for consideration, and as well for providing suitable training in an open way for wider groups of society, not only the junior ones who are just attending a vocational school or going to K-12 school, but as well senior citizens who are just, or senior professionals who are working in any kind of industry, who would need to see as well that kind of production is, well, skills are needed for new types of, I would say, digitally transformed and networked production. We have dealt with that in different projects and different activities. Just to give a few examples here. So just recently we have even won a prize for completing a measure together with vocational training centers, where we tried to share the equipment of one training center with another training center, because, for example, CNC machines are quite expensive, and it would be interesting to have a highly specialized device to be used by as well trainees from another college. And another activity is that we, for example, have developed and are running since quite some years a community for occupational safety specialists that are working as solely individuals in very different places, but need to be interconnected to their peers in order to guarantee a good quality of their activity. So connecting specialists, connecting working places and as well learning locations is one, or networking those hubs is one of the activities. And this is just an example how we used our learning management system of the vocational schools and the higher education institutes in our state to combine, well, following a production chain metaphor, the different CNC machines without having kind of physical mobility by either the technical infrastructures or the vocational trainees. And indeed, we implemented this collaboration between 3 vocational training centers in different cities of our local state in a way that the pupils may collaborate with each other, or the classes like in a business-to-business production chain, and could use non-physical configurations like data to implement a real production process and learn, or could make use of the technical infrastructures in different places by this type of collaboration. So implementing new ways of education and training is part of a routine that is heavily needed here. Let me now move on with the next step, considering the future of work and the digital transformation of skills toward more future skills. So one of the bigger challenges we have to deal with at this point in time is that different skill sets are needed in the industry. As I did describe before, new types of digitally transformed production processes having been implemented or are about to arrive, and the workforce is perhaps not fully ready to deal with that. We can see that the new type of job profiles are emerging, and as well we as education providers face different focus of our programs by a number of students looking for different approaches. On the other hand, as well, those who are working in industries since, let's say, a decade or even a generation, so the experienced workforce is as well challenged, because there is an skill shift or as well upskilling needed in order to stay in the workplace in a suitable way. And in Germany, we can observe that we even have a shortage of skilled workforce, because the demographic situation, which is completely different compared to Indonesia, challenges us a lot, as there is not so many young people arriving. And so we could not just easily take into account that the next generation with different skills would take over the responsibility for those different job routines. Indeed, there is a strong need, as well in ethical terms, of course, to provide measures for skill development for the already working people. And if you have a look into the technology development in different sectors, we can as well see that some of the activities may be handed over to machines or to technical configurations. Even in pedagogical context, we can see that many of our juniors have started to employ AI technologies in order to run knowledge-related, or to deal with knowledge-related demands, employing ChatGPT or other infrastructures on a personal level for supporting learning by kind of tutoring or mentoring like principals, besides the activity of the teaching staff. And here as well, we as teaching staff are demanded to rethink our pattern of professional activity in cooperation with the digital infrastructures that go alongside and that have already arrived into the classrooms or workshops. So one of the challenging questions is how we could partner in a good way with the so-called conversational agents, and what role do we hand over to the machines or to the data-driven infrastructures in context of working or learning or even everyday life routines. This, on the other hand, is not only, let's say, related to the workplace, it's a challenge for the wider society, where this new type of media has arrived, and on the other hand, may not replace the classically skilled worker, but may add some kind of new type of well, interactive pattern into very many routines. Finally, I perhaps as well surprising question is appearing, that's the question, who is responsible to train the AI? We are always talking about learning systems and learning AIs, and now the question is as well important, who is responsible for training AI? So not only asking for who is responsible for setting up the workplace, but as well who is responsible for training AI. And I like to address this question with a suggestion. Well, one may consider that the engineers and the computer scientists may be responsible for training or for programming the technology systems. On the other hand, I would say, well, let's consider that the educationalists in general or vocational education or in higher education are the experts for learning. And why not considering very seriously that there is a responsibility and as well a need to be able, as an educationalist, to train AI in a proper way to make use of that in any kind of well, educational process. So transforming skills is a very important aspect, and what we have developed as a design approach here is that we have combined in as well an international collaborative measure working and training into one activity. It seems to be difficult or not appropriate to fully separate training and work, and we see that especially for the workforce that is already in the workplace, it's not suitable to well, leave the workplace again and to go for another training, while then the new technologies or transformation of workplaces and working activities is taking place. And so there's a need to combine it and to interlink this and to make the training or to let the training happen in the context of work routines, however, in collaboration with other professionals and as well the digital infrastructures. And this is as well, let's say, a different principle compared to classic principles of training. When we employ those digital companions, or one could as well say just softwares or apps, as well, both as production technology, but as well as training partners and or instances. And so training may take place alongside working routines. Of course, one should have a focus on that. And in our project Moving, we did develop patterns how to combine those activities and as well to, well, conclude the learnings in a more well, precise way, which usually would have been overlooked into the happening during working routines. Okay, I will skip over the next one and come to my conclusions here in order to stay in time for our upcoming discussion. So if we talk about talent management with a strong link to technologies, then we can consider that and conclude that some different areas need to be well discussed. First of all, it seems that especially at the intersection to the workplace and to those working since short or long time, we have a need for curriculum development in order to provide appropriate measures, integrating the hands-on activities as well green technologies, but as well the identification of competences that have already been or that can already be found into the working routines. On the other hand, we need to take into account that we eventually do not have enough specialized instructors. So the training, the trainers or the teaching staff may not be available with a good in terms of numbers, but as well in terms of expertise. And so upskilling and looking for additional instructors is another aspect to deal with. And a third aspect is that the infrastructures may not be available for those different skills and transformed production processes in training facilities, especially not because perhaps there is not enough investment, but as well because the location of the learning is somehow shifting from the very institutional context in a physical infrastructure into digital locations outside the very school or the very training center. And this should be combined in a similar way as we do it today. I'm sitting in my private kitchen here, and you are at the conference site, and we are having this type of combination. I would say that this would not have been considered at all when, like, more senior persons like Professor Adi and me have been studying, let's say, a generation ago. This would have been unthinkable, but nowadays it's reality, and not because it's from different continents, but of course as well. So we see that this is it's a meaningful shift in implementing access to innovation and knowledge, especially in a large country like Indonesia, where there is such a variety of living contexts in very different territories. The next aspect I like to as well declare as important is the cooperation with different industries, different sectors of industries, as well in very practical terms. In Germany, we have the so-called dual system. We have training in vocational training, but as well in higher education is taking place at the intersection between the industry and the schools. And I can say that, for example, in one of the economically very successful states, which is in the southwest of Germany, we have a dual university, which is a highly popular and meanwhile the largest, by number of students, largest higher education institute, mainly financed by industry, because it combines in a very convincing way the practice in the industry during the studies and serves the needs of the industry, who then pays for it, and as well the the theoretical components of the higher education programs and bachelor and part and master level. And so the partnership with the industry could be a coining condition for a good quality education. Meaning, on the other hand, however, as well, that the industry is taking over responsibility for running trainings. And if this is not an easy development, not a simple development, but the partnership is very important because it guarantees that the training is in a special way meaningful for the later on to be fulfilled job routines. I would jump over the technological infrastructure aspect and come to the specific momentum of so-called soft skills. As we could see that the digital transformation and the implementation of AI systems leads to new types of collaboration and new types of human-machine interactions when those machines somehow accelerate to become partners or companions, and when the collaboration from the home is somehow contributing to work routines. then of course there is a new type of communication skills, or there's an additional portion of communication skills needed in order to successfully implement job routines, and such may be covered by curricular focus as well. And finally, what is a very ethical dimension is that not every learner, not every citizen may have equal access to resources, to society, and to cultural patterns in terms of well, collaboration and as well generating income or adding knowledge. And here we should have a critical and very open reflection of how to provide assistance as well in economic terms in order to lower thresholds for parts of a population or society that may be hindered to be part of this well, or to deal with the challenges in a rather appropriate and successful way. Yes, so if we sum up in a way, I would say, well, we have a good need for collaborating in between governmental agencies, the industries, and the education institutes in order to deal with the demands of new skills related to digital transformation, arrival of AI, open global collaborations, and as well the green technologies. And we may see that those inter-stakeholder collaborations would perhaps call for both for the organizational development, but as well for technologies in terms of new forms or new generations of media technologies. And this is, well, has been the focus of my talk here. And eventually there's now time for a discussion, and I just could invite as well to join one of the next conferences we are running, or to have some joint activity on site in your case, as we in your location at Pontianak Polytechnic, as we do today. Thank you very much for listening so far.
Okay, thank you, Professor. Give a big applause for Professor Kahler. Pardon, Professor? Before we start the question and answer session, I would like to ask you if is it allowed if we share your material with the participants of the seminar?
Yes,
Okay.
it is possible. I have sent it before.
Okay.
You may share it with the colleagues.
Thank you, Professor. And thanks again for that enlightening presentation. And we now have time for question from the audience. And now I invite the participant to ask their question, both in online and offline. Please state your name and affiliation before asking your questions. Thank you. Oh, okay. The committee, please pass the microphone. Okay.
I'm Fendi. I'm Fendi from Informatics Engineering. So, if you guys know about the CAI, character.ai, that's AI for make the character. You can make the character and it's like a chatbot. You can change the profile of the AI, and that AI can become that character. So I heard a news about the teenager murder himself because that AI. I think that AI doesn't have any limits to respond the audience. So my question is, what responsibility should developer and educational institution hold in creating AI tools that foster positive and safe digital interaction for students? Thank you.
Well, that's a big question, Mr. Wendy. Thank you very much for raising that. We just implemented a summer school together with colleagues in Indonesia, and we were discussing happily with PhD scholars from 10 different countries and as well professors from Indonesia and many other countries about the meaning of AI in context of education. And one of the learnings I have concluded is that indeed there is that we can see very interesting changes in implementing those technologies into individual routines for learning, but as well for innovating, for creating innovation, and as well for, I would say, socially collaborating with those technologies. So it's not just a database that is one or new interface to a database that is going to be used. This would be a rather classical term or classical understanding of a web 1.0 or 2.0 metaphor, and it's not as well something that we would call or compare with the classic industrial approach. It's indeed a new and highly innovative pattern of activity. My suggestion here is to indeed not to continue to consider media, including AI, as tools, but to see that it's not just a tool, it's more a collaborative instance or kind of a companion. And why not see that, or why not conclude that this may create a certain environment of creativity support that I can employ, or that I even have to employ in order to develop myself and as well define what routines of my activity for making a living are still suitable, and what could be supported by those infrastructures. This is, it's a big challenge. It sounds perhaps somehow too much challenging on the one hand. On the other hand, it is difficult to fully predict at this point in time how the near future may look like. What we have concluded from our research 6-7 years ago and presented at several conferences was that we would have expected that technologies become able to develop, and we tried a forecast of 10 years, and we predicted the technology would become able to provide learning material in an individualized way for a single learner in time, automatically. This was our very fancy suggestion some years ago. We said 10 years ahead, this may happen. It has arrived already now. I go to the AI, or you go to AI and ask, well, a certain question, and then it provides the most personalized setup. Still, we see limitations here. So quality is not always completely convincing, but this principle has arrived. And so what we may conclude from this observation is that indeed it's a technology for a highly individualized support in very different terms. So we get our personal assistants that are, let's say, much more powerful and much more personal, as well as the previous edition of Siri. And why not consider this as a strong and very useful need, that we not just have a textbook or a database in our pocket or backpack, but we have our personal assistant with us, and we may just consult this guy all time. And so we should reflect that this is our new companion. So thanks for your question. This was perhaps an incomplete reflection, but some feedback to you.
Thanks, Prof.
Okay, thank you, Mr. Effendi, for the questions. And maybe we have two two more participants to ask the questions. Oh, okay. Can committee just, okay, thank you. The microphone.
Okay, thank you, Professor. I'm Wiwit from Electrical Engineering Department. I have one question for you. If all work is done by AI, do you think human capabilities will not be reduced? And won't this make future generation too dependent on AI? I want to know how your opinion about that. Okay, thank you.
So if you see that such companion has arrived in our class activity, then perhaps we can as well consider that that becomes a regular routine. So it's not anymore just something that is available for technology specialists or for people with a very good access to resources. It's an everyday infrastructure that it's available for the wider society and for all citizens. And perhaps this is creating another, well, I would say, trigger for changing education. If such is arriving in any kind of production and training context and accessible without too much threshold. I mean, the question is then whether cultural routines that we have trained over generations or over an individual biography may be so stable that those are hindering making a fruitful use of the newly arrived infrastructures. And we have had such discussion previously with every wave of new technology arriving. I'm old enough, meanwhile, to have seen previous waves of when computers came to classroom or when the internet has arrived to the private household, and now the AI is coming to different industries. And we had always a discussion whether, let's say, it's a question of or a challenge for all the generations, and the younger ones would be more open. I think this still remains an issue if I see employees in the German industry where there is new skill demanded, then of course the industry and where there is not enough workforce, then with those skills, then the industry has started to run appropriate trainings for upskilling, and we should be open as well to accept that not everybody is very happy or very ready to adopt the technologies. However, then of course education may provide a good and additional insight. I don't know if this is answering your question, but it's just a glimpse of reflection from my side.
Okay, thank you, Professor.
Okay, thank you. And now we have break a minute, Professor, for 2 minutes. We want to your time like 2 minutes because in Indonesia it's pray time.
Yes, of course. Thank you.
And thank you very much, all the participants, ladies and gentlemen. And now we back to go our session with the last participant to ask questions. Oh, okay. We have a question. Okay, we have a offline participant want to ask a question. Please state your name and affiliation, please.
All right. Thank you very much for the opportunity. My name is Risa Syafutri from Architectural Engineering. Thank you, Prof, for such an intriguing materials. I'm very happy attending this seminar today. Well, as an architectural engineering lecturer, there's something that quite interesting for me. My question is first, are there any successful examples of vocational institution that transition from traditional method to green technology training? If so, what is the significant achievement that make it different? What is the successful story about them? What is the lesson that other vocational institution that would like to transition from the traditional method to green technology can learn, especially for the engineering field, from their experiences? Thank you.
Challenging question. Thank you very much. So green technologies may be considered as technologies with a pure focus on, let's say, the ecosystem and agriculture. I think this is too much limited. Often enough, we are talking about energy systems. This is as well a very important component. On the other hand, we as well have a focus on sustainability and a longer lasting, let's say, meaningfulness of the knowledge generated, and as well this aspect of sustainable knowledge is related to green technologies. And if we consider education institutions, whether they would be ready for or would be a good example for dealing with that, then we have some institutes that have set a focus on the various vocations or professions and implementing green technology vocations into their training programs. This would be one approach, but I think if this would be needed as a basic condition. However, green technologies really relate as well to future skills, and then this idea of sustainability and resource orientation, as well in terms of knowledge and immaterial goods, is calling for consideration as an overarching topic. And so it's not just to be dealt with into one single vocation or one single engineering domain. It's more of an overarching nature. And I am not aware of an educational institute that has tried to implement this into in a way that is not just a statement, but it is part of every education program. I think there is still opportunity or even need for focusing on or for refocusing, and it may become a basis for understanding the very vocations or the very subjects, to see that such may be a solid base for redefining, not skipping the engineering or skipping the whatever program away, but just to include this as a generic component into different programs. This I would see as a quite valuable contribution, but personally I'm not aware of an institute. However, I must confess that I did not implement a study or search for a study that could answer if there would be institutes that already follow such approach. I would guess one may find examples, but one would need to go for that. So I think your question is quite useful, but I cannot completely answer it. Thank you.
Sorry, thank you so much, Prof.
Okay, thank you very much. We're going to say hi to an online platform. Where is Mr. Can you introduce yourself and your affiliation? Mr. Azul. Mr. Azul. Okay, can you hear me?
Yep, I can hear you clearly.
Oh, okay, thank you. And the
Okay, you can hear me clearly also, right? Yeah, thank you very much for the opportunity. Hello, Prof. Kohler. I'm Zulfikar. Actually, I'm a lecturer of Politeknik Negeri Pontianak, but currently I'm doing my PhD in UK. I would like to ask you about your experience with Indonesian student while in Germany, especially ISMA, because we're expecting to get the democratic bonus in 2045. So how you feel, how can we optimist with this kind of phenomenon based on your experience involved with the current Indonesian student like ISMA and something like that? Can we be optimists? Is there any gap in knowledge and skill compared with the compared with Germany or European Union or other country in terms of the skill and knowledge to our Indonesian student currently?
Yeah, thank you for your question. Thank you for your question. So, having taught the ISMA group in several lectures last weeks, I can see that there is quite some enthusiasm and openness as well for well, working with diverse perspectives and experiences. I think this is very valuable. To this competency in well, dealing with diversity and well, different as well insights into problem solving, into yeah, into education and whatever activity. And so I don't see any limitation for that. I didn't fully get, you say in 2045 Indonesia is getting a democratic or demographic bonus?
Demographic, I mean demographic bonus.
Because it is, you mean the population will then be starting to age, or is this?
Yeah, they starting to within their productive age, and more people will be in their productive age.
Yeah, of course, and this is something that is well, it's a resource issue on the one hand. On the other hand, it's as well the society is population is getting older, and the period of work is extending, and as well the routines are perhaps not as physically not as demanding anymore. So work is less exhausting in a way, or may be less exhausting. So the character of work in the individual life may change, longer lasting and a different character, more related to knowledge. And I think this is something that does not happen overnight, but it changes society. One may observe as well Japan, where there is a quite old, long working population since decades, since many years. And this creates effects as well on a macroeconomic level onto society, but it may not be considered as a challenge. Of course, there is some shortcomings, or some demands we have now in parts of Europe when we have a quite old population. And some as well skills are disappearing because there is not so much demand, and then some skills in technical, in vocational, or in service-related domains are not available in enough number due to market needs. And this calls then for more global collaboration in order to employ additional workforce whatsoever, or ask for technologies. So I don't see that, well, there's a special challenge for Indonesia. I see lots of opportunities on the one hand. On the other hand, I see it is good to see how other societies or other economic systems have developed over decades, and then just to be aware of some shortcomings that may arrive. But at this point in time, I think it's not so close to Indonesian society, because society is rather young and still growing a lot as well in terms of net income and the size of the industry.
So you have any suggestion for our young generation, maybe?
Be as open as you are.
Okay. Thank you, Prof.
Thank you.
Thank you for Mr. Zulkifli Hasan, who joined us in online platform. Zulfikar, maaf, Zulkifli Hasan. Hah? Zulkifli Hasan? Oh, okay. Sorry, advertisement. Mr. Zulfikar Hasan, thank you. Sorry to wrong pronounce your name. Okay. Well, we have now reached the conclusion section. From what Professor Kahler has presented and the subsequent Q&A session. And here the underlying takeaways from these materials. And the convergence of AI and openness is transforming higher education, make it more accessible and effective by addressing challenges and fostering an environment of collaboration and innovation. Institutions can leverage these advancements to enhance educational experiences and outcomes. And Professor Kahler's presentation has provided us all with the valuable insights. And once again, thank you, Professor Kahler. Yeah. For your significant contribution to this seminar. Okay, once again, let's give a round, big applause for Professor Kahler.
Thank you so much for your openness and attention. Thank you. Wishing you a good completion of your conference.
Maybe Professor, do you want to? Oh, okay. Thank you. And dear ladies and gentlemen, and now we will take 15 minutes. We will take a 15 minutes of break and coffee break for you to relax, and please enjoy the time and coffee served. Thank you. Yes, silakan untuk menikmati kopi, dan mungkin untuk sholat bisa di sebelah kanan. Terima kasih.
Sama nasional dan internasional, Politeknik Negeri Pontianak telah melakukan berbagai kerjasama dalam bentuk seminar dan konferensi internasional serta kuliah umum di mana narasumbernya berasal dari berbagai negara. Politeknik Negeri Pontianak telah menjalin kerjasama dengan beberapa perguruan tinggi, baik perguruan tinggi di dalam negeri dan di luar negeri, pihak pemerintah, perusahaan, dan industri, serta asosiasi. Politeknik Negeri Pontianak juga aktif dalam mengirim dan menerima mahasiswa magang dan pertukaran mahasiswa baik di dalam negeri maupun luar negeri. Mahasiswa-mahasiswi Politeknik Negeri Pontianak juga memiliki prestasi yang gemilang, baik prestasi di bidang akademik maupun non-akademik, di tingkat nasional dan internasional.
Kami menghasilkan lulusan yang disiplin, jujur, bertanggung jawab, dan siap berkontribusi bagi kemajuan bangsa dan negara. Politeknik Negeri Pontianak,
tepat waktu, ukuran, dan aturan. Politeknik Negeri Pontianak merupakan salah satu perguruan tinggi vokasi yang ada di Kota Pontianak. Politeknik Negeri Pontianak menempati area seluas 6,3 hektar di tengah Kota Pontianak, Provinsi Kalimantan Barat. Politeknik Negeri Pontianak dulunya dikenal dengan nama Politeknik Universitas Tanjung Pura, yang pada awal berdirinya hanya memiliki 2 jurusan, yaitu Teknik Sipil dan Teknik Mesin. Politeknik Negeri Pontianak memiliki 8 jurusan dan 25 program studi di kampus utama dan 12 program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD di Kabupaten Kapuas Hulu dan program studi di luar kampus utama atau PSDKU di Kabupaten Sanggau dan Kabupaten Sukamara. Berikut ini 8 jurusan pilihan dan 25 program studi yang ditawarkan di kampus utama. Jurusan Teknik Sipil, jurusan Teknik Mesin, jurusan Teknik Elektro, jurusan Akuntansi, jurusan Administrasi Bisnis, jurusan Teknologi Pertanian, jurusan Ilmu Kelautan dan Perikanan, jurusan Teknik Arsitektur. Selain itu, Politeknik Negeri Pontianak mempunyai beberapa program studi di luar kampus utama, yaitu program studi di luar domisili atau PDD, dan program studi di luar kampus utama atau PSDKU. Masing-masing ilmu pengetahuan dan teknologi untuk mendukung era industrialisasi. Politeknik Negeri Pontianak memiliki komitmen penuh untuk senantiasa meningkatkan fasilitasnya demi mendukung penyelenggaraan pendidikan dan pengajaran yang unggul untuk para peserta didiknya. Untuk mengoptimalkan proses pembelajaran yang menitikberatkan pada penguasaan nilai praktik demi mendukung teori yang dipelajari, setiap jurusan di Politeknik Negeri Pontianak dilengkapi dengan fasilitas sarana dan prasarana berupa laboratorium dan bengkel yang dapat mendukung bidang ilmunya masing-masing. Mahasiswa Politeknik Negeri Pontianak akan menjalani hampir 60% dari masa studinya dengan praktikum di laboratorium ataupun bengkel untuk menerapkan ilmu dan mengembangkan keahlian mereka sebagai fokus utama dari konsep pendidikan vokasi atau keahlian. Selain itu, Politeknik Negeri Pontianak juga dilengkapi dengan berbagai fasilitas lainnya, seperti ruang kelas yang representatif, internet nirkabel, perpustakaan, poliklinik, lapangan olahraga, asrama mahasiswa, bank, masjid, ruang rapat, gedung aula terpadu, dan Polnetmart. Politeknik Negeri Pontianak juga berperan aktif dalam penelitian dan pengabdian pada masyarakat. Berbagai kegiatan telah dilakukan, seperti pemberian pelatihan bagi masyarakat yang membutuhkan penerapan teknologi, pemberian bantuan alat, dan kegiatan-kegiatan lainnya. Sebagai lembaga yang memiliki komitmen tinggi untuk menjalin kerjasama nasional dan internasional, Politeknik Negeri Pontianak telah melakukan berbagai kerjasama dalam bentuk seminar dan konferensi internasional, serta kuliah umum di mana narasumbernya berasal dari berbagai negara. Politeknik Negeri Pontianak telah menjalin kerjasama dengan beberapa perguruan tinggi, baik perguruan tinggi di dalam negeri dan di luar negeri, pihak pemerintah, perusahaan, dan industri, serta asosiasi. Politeknik Negeri Pontianak juga aktif dalam mengirim dan menerima mahasiswa magang dan pertukaran mahasiswa baik di dalam negeri maupun luar negeri. Mahasiswa-mahasiswi Politeknik Negeri Pontianak juga memiliki prestasi yang gemilang, baik prestasi di bidang akademik maupun non-akademik, di tingkat nasional dan internasional.
Kami menghasilkan lulusan yang disiplin, jujur, bertanggung jawab, dan siap berkontribusi bagi kemajuan bangsa dan negara. Politeknik Negeri Pontianak,
tepat waktu, ukuran, dan aturan. Politeknik Negeri Pontianak.
Okay, good afternoon, ladies and gentlemen. And we cordially invite you back to have a nice sit and especially back to your position because in a few minutes, this session will proceed in no time. Thank you. Distinguished guests, ladies and gentlemen, welcome back to our agenda, the seminar and discussion session that will be handled by our moderator, Mr. Suharsono Eskom Mkom, and floor is yours. Thank you.
All right. Thank you, Mr. Jajang. Good afternoon, Mr. Yanuar.
Yes. Assalamualaikum. Selamat sore.
Warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. It is an honor and pleasure to welcome you all the last session of this international seminar. We are delighted to share the stage as moderator, gathering together with so many extraordinary individuals. Allow me to introduce myself. My name is Suharsono, and I am a lecturer and the coordinator of Information Technology Study Program at PSDKU State Politeknik of Pontianak in Sukamara Regency. It is special honor for me to be part of the international seminar moderator by the Electrical Engineering Department of the State Politeknik of Pontianak. Di sesi yang terakhir ini, Bapak Dr. Yanuar, mungkin kita bisa menggunakan bahasa Melayu gitu ya, karena dari tadi pagi kita sudah pakai bahasa Inggris, sudah cukup penat gitu ya, para audiens kita. Mudah-mudahan penyampaian dari Dr. Yanuar nanti bisa memberikan kesan meskipun kita berada di sesi yang terakhir, kita bisa. Dan topiknya sangat menarik sekali nih terkait dengan energi yang ada di Provinsi Kalimantan khususnya seperti itu. Baik, sebelum kita masuki ke sesi yang terakhir, saya akan bacakan profil singkat dari Insinyur TS Dr. Yanuar Zulardiansyah Arif. Beliau merupakan dosen di University Malaysia Sarawak, Unimas, Malaysia. Beliau menekuni bidang teknologi tegangan tinggi, teknik tenaga listrik, nano dielektrik, dan energi terbarukan. Baik, pada sore hari ini di sesi yang terakhir kita, Pak Yanuar, kita punya waktu 25 menit. Nanti Bapak Yanuar akan menjelaskan atau memaparkan tentang topik dengan judul Development of Nuclear Power Plant in West Kalimantan, How Urgent Is It? Ya, kita punya waktu 25 menit, Pak Yanuar. Kemudian nanti akan kita lanjutkan dengan sesi tanya jawab kepada Bapak. Waktu disilahkan.
Oke, terima kasih Pak Suharsono dan rekan-rekan semua, Pak Jajang juga. Our moderator for this international seminar today. From the morning I watch everybody very enthusiastic. I'm motivated. I'm also become delightful even though I'm the last. Yeah, hopefully everybody still have the patience. Masih sabar. Yeah. As a lecturer, we have this is kind of the such critical time. I believe. Saya juga ada kelas, saya ada kuliah jam 4 sampai jam 6. It's quite difficult to deliver the material to our student with after the hard working day. Okay, let me share our screen. As mentioned by our moderator, I can mix with bahasa Indonesia. I'm very happy.
Yes.
If you mention in early, I better I don't prepare in English.
Yes.
My slide. Okay, hopefully my slide can be seen for the all audience. Again, I'm very delighted with this invitation to share something quite urgent with us. Hopefully this last topic, even though look like it's not so in line with our topic of the seminar today, but I think it's quite good for us because we are already everybody in the West Kalimantan province, our lovely hometown. I'm also from the Pontianak, Kalimantan Barat. Previously, I intended to come together with you all there, but because of the unavoided circumstance, I cannot able to come there. I'm so sorry again. Particularly for my friend, Mr. Hassan. I'm from research group of High Voltage Engineering Technology. This is my part of the discussion. Saya lebih suka menyebutnya sebagai diskusi lah, because this is not a really new thing or the new knowledge for us. This is the sharing information. To increase our awareness, kesadaran for us about the plan. Actually, this is plan, plan meaning rencana. But it's quite recently we listen, we read from many platforms, online media and so on about the plan of the construction or development of nuclear power plant. In our word, in PLTN, pembangkit listrik tenaga nuklir. The question is, how urgent is it? Berapa penting the urgensi pembangunan ini? Okay, I try also to make in line with our discussion today. Everybody talk about AI, IoT, IIoT, machine learning, deep learning. So I want to show our true color as well. What is the application of AI in high voltage engineering technology? I try to catch up everything in 20 minutes. Okay. Okay. As we can see, this is some news lah. I took from online media platform. They mentioned that the plan to construct PLTN, or nuclear power plant in Indonesia, particularly in the West Kalimantan province, in our province, around 2030, 2034. Stated by our BRIN. Previously, the agency to responsible with this idea is Batan. In 2021, Batan merged, dilebur di dalam BRIN, including DP and other Puspitek, become the big agency we call as the BRIN. Okay, the other news come from the online Tempo. It is quite the famous media in Indonesia, but this is an English version. Similarly, it reported also the idea or the plan to construct or develop PLTN in Indonesia around 2030, stated by Madam Ibu Enia LD, beliau Dirjen EBT, Energi Baru dan Terbarukan, Kementerian SDM Indonesia. I'm not sure what is the hold this post because we have the new minister in this ministry. But it's okay. This is the official document atau jejak digital that we can see about this. Oke, saya ingin coba kita mendiskusikannya secara ilmiah dalam koridor akademik, bukan dalam koridor politik, bukan dalam koridor sentimen dan sebagainya. Kita sebagai akademisi, kita sebagai student, we have the open mind with any information, and then we filter it, and then we give our own opinion based on the such kind of information. First of all, we would like to see the technical point of view about this issue, continued by what is the financial aspect, environmental, last but not least about the policy or regulation, peraturan regarding this issue. Let me go to the technical. This is the data of Indonesia keperluan energi dan potensi energi. As you can see, the current power generated. Ini penduduk Indonesia saat ini sekitar 260 juta. This is quite big human resource actually, workforce, and so on. And the other thing, we have potential for renewable energy. We have the potential about sekitar 416 gigawatt. Sebagai orang elektro mungkin kita tahu ya, giga ini berarti 10⁹. Suatu jumlah yang sangat besar. We back to the previous question, the main question as the topic of my discussion in the beginning. Dengan data seperti ini, dengan potensi cadangan energi baru terbarukan 419 gigawatt, apakah masih relevan? Apakah masih urgent? Pembangunan atau rencana pembangunan PLTN di provinsi kita. Okay, this is the we look in the energy potential in Kalimantan. I took directly, saya ambil secara langsung dari RUPTL, Rencana Umum Pembangunan Tenaga Listrik PLN. This is macam laporan dari PLN setiap periode, ini 2021, 2030. As we can see here, seperti kita dapat lihat di sini, jumlah pembangkit menurut jenis, ini dalam bahasa Indonesia karena laporan ini dalam bahasa Indonesia. Jadi untungnya mudah dipahami nggak perlu saya terjemahkan. Jadi kita fokus yang renewable terbarukan seperti ini, PLTM, mikrohidro, PLTA, air, PLTA surya, dengan yang basic ada sekitar lebih dari 1 giga 1,8 sekian. Kemudian pembangkit yang konvensional seperti biasa uap, gas uap, gas, mix gas, tetap masih kita manfaatkan. Oke, apa yang dapat kita simpulkan? What we can conclude from this table, we can see the additional tambahan kapasitas pembangkit dalam rentang 10 tahun, bermula tahun 2021 kemarin sampai 2030 itu sekitar 2.8 gigawatt. 2.8. In average addition around 280, pertumbuhannya rata-rata setiap tahun 280 megawatt. Dari porsi sekian 2,8 gigawatt ini diikuti oleh cadangan atau sumber energi terbarukan termasuk PLTS, angin, dalam terminologi Indonesia wind power plant we call as the LTB, pembangkit listrik tenaga bayu, karena nanti kalau ada B satu lagi itu biodiesel dan sebagainya. Oke, biomass itu sebesar 459 megawatt. Jadi total sekitar 58%, which means artinya lebih dari setengah supply energi kita dalam rentang nanti sampai 2020 itu datang dari sumber energi terbarukan. Oke, kemudian ada skenario dari PLN. Sorry. Saya tertekan tadi ini maaf. Ada skenario dari PLTN. Slide saya tertutup atau gimana? Masih?
Masih kelihatan.
Masih kelihatan. Saya nggak ngelihat sekarang. I cannot see my own screen. Karena Maaf, apakah masih terlihat?
Masih.
Rekan semua masih ya?
Masih terlihat.
Terlihat ya. Oke. How do make is the full screen? Sorry. Saya stop dulu ya. Sorry. So sorry. Let me open again. Okay, already here. Okay, another scenario from PLN, our state, our company, is to make interconnection. As we know, we do not need to produce our own power plant. Kita nggak perlu ada pembangkit sendiri, as long as kita bisa menginterkoneksi dengan sumber-sumber lain. Salah satunya sebagai wilayah Kalimantan yang sudah mulai terintegrasi, kita bisa interkoneksi dengan Kalsel, Teng, Timra, ya, Kalimantan Selatan, Tengah, Timur, dan Utara. Our system in Kalbar, we call it the Katulistiwa system. Karena di Kalsel, Kalteng, Kalimantan Timur, ya, Utara memiliki sumber-sumber pembangkit yang cukup besar, ya, hidro, terutama hidro, ya. Kemudian, as mentioned in RUPTLPLN tersebut, ya, senario untuk menggantikan, ya, dengan energi EBT ini masih belum ada, ya, dalam skenario PLN. Ya. Artinya kita masih memanfaatkan sumber-sumber yang ada sekarang dengan perencanaan ke depan, ya, dengan jumlah pembangkit yang ada sudah bisa mengcover kebutuhan beban di Kalbar dan Kalimantan pada umumnya. Ya, untuk Kalbar beban puncak sekitar 470-an megawatt. Ya. Kemudian dari sumber berita yang kita peroleh di atas, ya, rencana yang akan dibangun, ya, oleh BRIN tersebut, ya, PLTN yang dibangun ini tipe reaktornya SMR, ya, Small Modular Reactor. Ini sebenarnya skala kecil, ya, skala kecil sekitar 100 megawatt. Ya. Tidak terlalu signifikan, tapi menurut PLN masih memerlukan in-depth study, ya, menurut penelitian yang mendalam dari segi sustainability, kelestarian, ya, sosial, ya, antara penerimaan masyarakat, ya, keekonomian maupun masalah peraturan di negara kita. Ya. Oke, that's for the technical. We go to the financial. Ya kan, kalau kita ingin membeli sesuatu barang, ya kan, kita pasti melihat kira-kira berapa costingnya, ya kan. We know electric car is very nice, very good, but we compare the conventional car, currently the price is quite high. That's why we have to make some comparison first. Kita buat review, kita lihat. Nowadays, interestingly, from this source you can see the red one is for the PLTN, pembangkit tenaga nuklir. It's the second highest cost compared with the renewable energi terbarukan. The lowest one is the PLTS, diikuti oleh geothermal. Unfortunately, we don't have resource for geothermal in Kalimantan because there is no volcano. Nah, ada gunung berapi di Kalimantan, ya. Okay, from this data we can see clearly, ya, kita bisa lihat dengan jelas penurunan, ya, ongkos atau biaya produksi per megawatt jam, ya, dari pembangkit listrik terbarukan dibanding dengan pembangkit listrik konvensional termasuk nuklir. Ya, umumnya, ya, mostly, ya, kita lihat ini angin bisa dibagi dengan offshore. Offshore ini yang lepas pantai, ya. Jadi angin ini bisa di lepas pantai, bisa juga di darat, ya. Dua-duanya turun, walaupun nggak terlalu signifikan, tapi kecenderungannya turun dari 2009 ke 2019, ya, sekitar 9-10 tahun. Ya. Kemudian yang paling signifikan, ya, PLTS. Ya. PLTS komponen terbesar panel suryanya, ya, bukan teknologi material, manufacture process, improve, so bisa mengurangi ongkos produksi sehingga total komponen, ya, cost of energy untuk PLTS itu jauh menurun, sangat signifikan, ya, sekitar 90% penurunan dibanding tahun 2010. Ya. Meanwhile, sementara itu kita bisa lihat, yang lain trennya turun. PLTN, this is not from me, this is data from international data, our working data. Clearly, you can check again in internet. I give the link to you in our references. Nuclear increase, batu bara, including PLTU, dan sebagainya, almost constant lah, ya. $2 lah, ya, kata orang Melayu, jangan dikira sangat lah, ya. $2 itu bolehlah cincai, ya. Maintain, remain, ya. Tapi yang EBT significantly decrease. Okay, so I will skip this. This is just give you some wording, ya, emphasizement lah, ya, penekanan penurunan tadi, ya. Sementara nuklir naik, ya, EBT turun, ya. Sekitar 5 kali lebih murah, ya, dibandingkan dengan nuklir, ya, terutama PLTS dengan wind, ya. Kemudian dari sumber yang kita dapatkan tadi, ya, dari jejak digital yang kita bisa lihat, BRIN merencanakan atau meminta budget anggaran, ya, sekitar 2.000 billion, ya, rupiah. 2.000 billion ini saya nggak ngerti ini, ya. Udah jadi triliun kali, ya, atau sekitar 125,7, ya. Saya pun nggak pernah lihat uang sebanyak ini, ya. 125,7 juta, ya, US dollar, ya, untuk SMR PLTN dengan kapasitas sekitar 40 mega, ya. How expensive, ya, this cost, ya, sangat mahal. Ini analogi juga, ya, ini skenario di Amerika. Kalau kita mengganti satu pembangkit tenaga nuklir itu sama dengan kita bisa elektrifikasi sekitar 1,6 juta household rumah dengan biaya sekitar 20 billion US dollar, sedangkan untuk PLTN 41 billion, jadi double, ya, sekitar double. Kemudian untuk workforce tenaga kerja, ya, yang dihasilkan itu sekitar 220.000, ya, orang bisa dipekerjakan, sedangkan di PLTN hanya sekitar 2.400, ya, 1/10-nya. Oke, kita ingin lihat pemetaan pembangkitan PLTN di dunia, ya, menurut data sampai 2020 Juli, ya. Kita lihat di sini hanya beberapa negara, ya, yang masih bertahan, ya, mempertahankan PLTN dengan pembangunan baru, umumnya kurang dari 5, kecuali Cina, India, ya, yang masih di atas 10. Yang lain hanya maintain, mempertahankan yang sudah ada, kemudian tidak membuka, membangun PLTN yang baru, ya, no new construction of nuclear power plant. Sehingga sekitar total sekitar 52, ya, pembangkit baru dengan kapasitas sekitar 53 giga, ya, sekitar untuk beberapa tahun ini. Kemudian yang delay, artinya yang proyek yang tertunda itu sekitar 33 unit, ya, karena masalah currency, ya, masalah political, social, and so on. Oke, yang menarik lagi dari data nuklir industri, ya, ini rumahnya lah, ya, nuklir dunia. Data yang mereka keluarkan, kita bisa lihat dari tahun 2023 sampai 2050, proyeksi pembangunan PLTN, ya, mulai dari 2030 itu sudah menurun. Dengan kata lain, lebih banyak yang tutup, ya, tidak ada yang dibuka baru, ya. Grafiknya negatif, ya. Artinya penutupan, ya, pembangkit-pembangkit lama, ya, sedangkan pembangkit baru tidak dipakai. Ya, sedangkan, however, you can see for renewable energy ini dikatakan boom, ya, dikatakan boom karena significantly increase. Ya. Kita lihat di sini 2020 dibandingkan 2019 sekitar 10 tahun peningkatannya sekitar 2 ya, double. Ya. Contradiction compare with the nuclear power plant yang semakin decline or decrease. Ya. Okay, next we can see the issue of perspective environmental perspective. It can be summary from here. The problem if we construct or develop PLTN, or nuclear power plant. First of all, about the radioactive waste. This is long-lived and hazardous bioproduct. This can take 1,000 years. Waktu luruhnya. I think some of we from the chemical engineering. Is there any chemical engineering here? Potential consequent health risk, environmental contamination. So the waste, the limbah of the nuclear ini, limbah uranium, kalau kita menggunakan uranium, itu nggak bisa dibuang begitu saja, nggak bisa di recycle, it's very difficult. Kita hanya boleh keep dalam tempat kontainer, atau dalam apalah yang tertutup rapat, di atas gunung, di dalam gunung, di bawah bukit, seperti itu. Jadi some issue ada yang menyatakan mau buang di ruang angkasa dan sebagainya, tapi itu cost semuanya. Mining and refining ini pertambangan dengan penyulingan, prosesnya memerlukan proses yang panjang. Kita diwar-warkan itu bahasa Malaysia, didengung-dengungkan dengan adanya cadangan uranium, thorium dan apa dan sebagainya di wilayah kita. Tapi itu bukan sesuatu yang kata orang Melayu bisa dicedok langsung bisa dipakai. No, it need take process. Everything costing. Itu ada pengayaan istilahnya, enrichment of uranium in order to be used in nuclear power plant. Kemudian pollution, heat discharge, accident risk. Kecelakaan nuklir ini nggak perlu sering, sekali tapi langsung finish. The common, okay, this is greenhouse gas emission. I don't want to take long time for here. Kita bisa lihat di sini. Nuclear is quite good in terms of the gas emission. Okay, this is if want to show the benefit, cannot hide. Kita nggak boleh sembunyikan. Tapi solar juga bisa menghemat sekitar 5 ton. Wind bisa mengimbangi. Tapi dari sisi aspek yang lain, nuklir sangat membahayakan limbah atau bila terjadi kebocoran atau terjadi kecelakaan, accident. Sorry, this graph is not so clear. I want to show you briefly, secara ringkas, secara singkat, kecelakaan nuklir dari tahun 56, walaupun nggak terlalu di-expose, The recently, I think we all remember 2011 Fukushima Daiichi in Jepang. Sampai sekarang Jepang masalah menyimpan air untuk meningkatkan reaktor yang meleleh itu. I think a few months ago, pemerintah Jepang terpaksa membuangnya ke laut lepas walaupun diprotes oleh negara tetangga, Korea Utara, Korea Selatan maupun Cina. Tapi Jepang menjamin itu sudah di-treat, sudah diolah dan membahayakan kepada laut. Kemudian yang besar kemudian tahun 86 Chernobyl, everyone know about that, and some small incident in nuclear. This is the aspect of the environmental. In case accident or the leaking of the reactor. Last but not least, about the regulation or policy in our country. According to our national energy policy, kebijakan energi nasional, nomor 79 tahun 2014, dan National Energy General Plan, RUEN in bahasa Indonesia, Rencana Umum Energi Nasional, nomor 22 tahun 2017, yang saya ringkas di sini, penggunaan energi nuklir dipertimbangkan, setelah penggunaan sumber energi baru dan terbarukan dimaksimalkan. Ya. Ini udah saya terjemahkan ke Inggris, saya terjemahkan lagi ke bahasa Indonesia ya. Mengingat potensi yang sangat besar dari renewable energy, dari energi terbarukan, the use of the nuclear energy, energi nuklir adalah last option. This is not my statement. This is our regulation. Teks aslinya dinyatakan sebagai pilihan terakhir. What does it mean? Kalau ada pilihan terakhir berarti kita gunakan dulu yang sedia ada. The available one. This is same lah. Similarly in our tadi kebijakan energi nasional, natural energy general plan, bahwa aspek security, keamanan, itu menjadi pertimbangan, makanya menjadi pilihan terakhir dengan perhatian, dengan mempertimbangkan sangat keras aspek keselamatan, aspek keselamatan. Jadi nuclear power plant implementation in our regulation state that the roadmap harus dipertimbangkan, disiapkan sebaik mungkin menyangkut aspek teknologi. Apakah kita benar-benar memiliki teknologinya, atau kita hanya sekedar sebagai supplier, atau negara kita nanti dijadikan sebagai tong sampah, dari reaktor-reaktor bekas dari negara lain yang sudah shutdown reaktornya, atau kita yang sebagai tuannya. Nah, itu yang kita harus garis bawahi. Kemudian jenis bahan bakar yang akan digunakan, apakah uranium kita memang benar-benar mencukupi, kualitasnya memang yang terbaik, lokasinya, apakah benar di Bengkayang itu lokasi terbaik, keamanan, pendanaan, and human resource readiness, kita punya SDM, diikuti dengan multi criteria analysis. This is the regulation, statement. I just restate, in English. So, as the conclusion of the first part, di bagian pertama, sebenarnya bukan conclusion. Saya hanya menanyakan kembali. Pertanyaan ulang, saya tinggalkan this answer to you all. Jawabannya kepada audiens semua. Apakah masih perlu atau ada urgensi atau memang sangat mendesak pembangunan PLTN terutama di wilayah Kalimantan Barat. I think that's all from our part. Is there any time for me? Kalau enggak, saya skip aja bagian kedua. Pak Suarsono?
Waktunya sudah habis.
Sudah habis, oke. I will give to you all my slide later to the committee. Ini hanya sharing aja ya. Oke, silakan kita open Q&A, question and answer session. Thank you.
Oke, thank you Mr. Yanwar. Baik, selanjutnya kita masuk sesi pertanyaan kepada audiens yang ada di ruangan maupun yang ada di ruang Zoom. Disilahkan untuk memberikan pertanyaan kepada narasumber terakhir kita. Silakan. Ya. Dari ruangan accounting hall ada yang ingin bertanya, disilahkan. Tolong mic-nya diberikan.
Silakan.
Oke, silakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Perkenalkan, nama saya Natasha Melinda dari program studi Teknik Informatika. Saya ingin bertanya, Pak, berdasarkan penelitian Bapak, apa saja potensi sumber energi terbarukan yang paling menjanjikan di Kalimantan Barat dan bagaimana kecepatan pengembangannya dibandingkan dengan PLTN? Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Baik, apakah langsung jawab atau kita tunggu pertanyaan lain?
Langsung dijawab saja, Pak.
Langsung dijawab. Terima kasih. Pertanyaan yang sangat menarik. Ini ciri-ciri mahasiswa cemerlang, excellent student. Oke, untuk wilayah Kalimantan Barat, biomass, salah satu potensi yang bisa kita manfaatkan. Biomass ini organik, sampah organik, limbah kelapa sawit, Kita ketahui di negara kita memiliki banyak sekali perkebunan kelapa sawit, terutama di Kalimantan Barat. So limbah kelapa sawit di bidang lain juga dimanfaatkan ya, mungkin di sipil untuk penguat ya, filler konkrit ya. Tapi bisa juga kita manfaatkan sebagai bahan bakar biomasa, ya, biomas atau sisa-sisa plywood ya. Limbah industri atau dari peternakan ya, kotoran hewan ya bisa kita manfaatkan sebagai biogas atau sampah rumah tangga ya, sampah tangga di Siantan kalau nggak salah ya, ada PLTSA pembangkit listrik tenaga sampah ya, itu udah running, udah commissioning. Saya lupa berapa megawatt ya, tapi itu swasta ya, swasta tapi it's okay. Itu menunjukkan bahwa kita bisa memanfaatkan sekitar kita. Jadi kalau tadi kita pikirkan 100 megawatt atau 40 megawatt PLTN yang akan dibangun di Kalimantan Barat sudah dapat di-cover oleh energi terbarukan, PLT sampah, biomass, ya, biogas, ya, fuel cell, ya, itu memiliki potensi yang sangat besar. Ya. Cuman kita biasanya apa ya kelihatan nggak prestis ya, nggak bergengsi gitu kan, ya kan. Jadi salah satu yang harus kita benahi ya pemikiran bahwa kita belum menjadi negara maju kalau kita belum ada PLTN. Itu pemikiran yang salah ya. Pemikiran kita bisa memanfaatkan our environment. Nah, ya kan? Kita back to our environment ya. Tendensi kita kan sekarang ke green, ya, renewable, sustainable, ya, biodegradable, ya, yang lebih environmental friendly, ya. Kalau sekedar menyebut contoh, ya, negara-negara besar seperti Perancis, ya, I'm not sure, ya, our professor kalau is still here, Germany, ya, Jerman juga sudah mengurangi, ya, kalau tidak dikatakan meninggalkan, ya, PLTN. Ya. Itali sudah zero, sama sekali nggak ada. Ya, walaupun dulu Batan ya, isu PLTN ini udah lama ya dari tahun 80-an. Kalau ingat di Jepara dulu ya udah mau dibangun ya. Dulu kita berkolaborasi Batan dengan Itali. Ya, apa yang terjadi dengan Itali? Sekarang PLTN sama sekali nggak ada di Itali. Ya, Itali nggak memanfaatkan PLTN. Jadi kita kali kembangkan potensi yang ada di sekitar kita. PLTS juga sangat besar di Kalimantan Barat. Kita negara ekuator, khatulistiwa, ya, luar biasa potensinya. Ya. Sekitar 2.000-an gigawatt ya Indonesia total untuk PLTS. Tapi yang baru dimanfaatkan baru ratusan megawatt. Ya. Bisa jadi PLTS atap, ya, rooftop. Ya. PV bisa jadi floating ya, misalnya kita manfaatkan hibrid ya, di bendungan-bendungan ya, PLTA itu kan ada bendungan. Nah, jadi yang bendungannya itu kita manfaatkan PLTS terapung. Itu banyak diterapkan di beberapa negara termasuk di Malaysia ya. Saya pikir itu yang dapat saya sampaikan ya, mudah-mudahan dapat menjawab persoalan dari rekan kita tadi.
Terima kasih, Pak.
Sama-sama.
Baik, terima kasih Pak Yanuar. Berikutnya untuk penanya selanjutnya, disilahkan. Ya.
Okay, thank you, Dr. Yanuar. I'm Wiwit from Electrical Engineering Department. I have two questions for you. First is, what is the main cause of the decline in the use of PLTS? Is it because of the high initial capital required to build and maintain PLTS? And the second question is West Kalimantan ready to build a nuclear power plant? Because as you say, nuclear power plant waste cannot just be thrown away. What is the solution regarding nuclear power plant waste? Thank you.
Okay, thank you, Mbak Wiwit ya. We had same program from Political Department. I think you know about this concept, ya. Penurunan, ya, the decline, ya, decline of the PLTS, meaning solar PV, ya. What is the cost of energy solar PV itu menurun. Menurun artinya menjadi lebih murah, ya. Cheap and become cheaper, ya. Mostly disebabkan oleh cost of production of solar panel, panel suryanya itu sendiri, ya. Because of the improvement of the material, the type of the solar panel. Dulu kita punya polycrystalline, sekarang monocrystalline. The increase of the efficiency of the material, and then large scale production, like China produce very massive, solar panel production, even China investment also in Malaysia, also in the Sarawak. If you know about the Longgi and the name of the solar panel producer, I'm not sure. I heard also Indonesia we have solar panel factory or manufacturer. That's the first, because of the material. Because the most component, the main component of the PLTS, pembangkit listrik tenaga surya adalah panel suryanya. Of course, inverter, kalau kita off grid kita perlu baterainya memang ada cost, tapi yang paling besar itu panelnya. Inverter juga semakin menurun harganya sehingga bukan sekedar berkompetitif, harganya nggak berkompetitif lagi, jauh lebih murah, sekitar 5 kali dari ongkos produksi kalau kita istilahnya face to face bandingkan dengan PLTN. That's the answer for the first question. The second one, tadi apa? Alhamdulillah, usia ada di atas 50 nih mengalami kemunduran memori.
Is West Kalimantan
West Kalimantan, okay.
ready to build
Ready, okay.
power plant?
I return back this question to you all. Are you feel we are ready to that? Apakah kita hanya jadi penonton, spectator, ya kan? Kalau nonton konser musik kampus, oke, no worries. Ini yang kita tonton adalah suatu teknologi yang asing bagi kita, ya kan? Apakah ada jurusan teknik nuklir di Polnem?
We don't have.
Don't have, right? So mostly the worker, even in Untan, I heard no such kind of the study program, ya kan? The expatriate, the imported everything, Batam is the research center, not of the nuclear power plant company. The biggest Batam reactor, this is for the research, 10 megawatt, with the cost almost 2 trillion. 10 megawatt dengan biaya pembangunan sekitar 2 triliun, itu istilahnya reaktor penyelidikan, penelitian. Jadi kesiapan kita baik dari segi sosial, artinya bisa konflik horizontal lah, masyarakat kita sangat rentan isu-isu ini, Again, masalah pendidikan juga menjadi isu utama, masalah teknologi, kita terus terang teknologi SMR sendiri, small modular reaktor itu sebenarnya masih generasi ketiga dari PLTN, bukan yang terakhir, Fukushima itu pun udah menggunakan generasi ketiga, artinya yang udah dibangun tahun 60-an 70-an, itulah kerancuan di terminologi di kita, ini untuk pikiran kita bersama, istilah EBT ini hanya ada di Indonesia, energi baru dan terbarukan, I'm not sure in Germany, I check already. Yang pakai istilah energi baru terbarukan, new energy and renewable energy, only Indonesia, in the other country only, I search internet, only India, I'm not sure we copy from India atau India copy from us, nggak tahu yang siapa mengopi siapa. Tapi yang ada sebenarnya di dunia ini hanya renewable energy and nuclear energy. Ya. Jadi kita ini ada dalam dilema. Jadi nuklir kita masukkan di dalam EBT, energi baru, ya, bersama dengan hidrogen dan bersumber-sumber lain. Jadi begitu nanti RUU EBT masuk, ya, disahkan. Sekarang masih perdebatan ya sampai DPR yang lama pun sudah diganti, itu masih belum diratifikasi ya, belum disahkan RUU EBT ya, energi baru terbarukan. Tapi nuklir ada di dalam itu. Itu yang jadi isu. Karena target kita bauran energi mix energi supply to Indonesia until 2025 itu 23% dari EBT. Ya, dari energi baru terbarukan. Jadi karena energi baru itu ada di situ, jadi para pengusung PLTN ini memanfaatkan terminologi itu, ya. Walaupun dari segi teknis yang saya sampaikan tadi, financial, environmental maupun regulation itu memberikan peluang lebih besar kepada energi terbarukan, ya, renewable energy. Ya, demikian dari saya Mbak Wiwit yang dapat saya sampaikan. Semoga dapat menjawab.
Okay, you think we are ready, but depend the regulation from our government, right?
To me myself, I think we are not ready. Yeah, we are not ready. Yeah, compared with many aspects. Yeah.
You hear about that?
Who is the human resource? Yeah, we have the human resource. Yeah, not from us. Yeah, we are only kata orang ketempatan. Ya, ketempatan. Kok ketempatan yang bagus nggak apa? Ya. Ini ketempatan sesuatu ibaratnya time bombing, ya, bom waktu, ya, bom waktu, very dangerous, bukan menakut-nakuti, ya, bukan menakuti.
Because
Yes, ya. Jepang terus terang, ya, Jepang very disciplined people, ya. I study about 4 years in Japan, sangat disiplin, tapi masih ada terjadi kebocoran, ya, kebocoran. Orang kita jalan bagus-bagus, divider itu dihancurin supaya bisa U-turn. Ini jauh katanya kalau mau putar balik, ya, dihancurin, ya. Suka shortcut, ya, suka shortcut. I'm afraid nanti kalau kita ada PLTN, semua dari level bawah sampai atas itu bukan orang kita yang kerja, ya. Semuanya dari luar, ya, dari luar. Karena our culture is not there, ya. Budaya kita masih belum sampai di sana, ya. This is my opinion. It's open for everybody lah. You have your own opinion. Kita sebagai orang independen, ya, bebas merdeka. You have your own opinion with your scientific reason behind it. Okay, thank you. That's all from me.
Okay, thank you, Dr. Yana Yanuar.
Okay, sama-sama.
Oke, terima kasih Bapak Dr. Yanuar. Seperti yang tadi, meskipun kita berada di sesi yang terakhir, tapi topik ini sebenarnya sangat menarik. Namun karena kita dibatasi oleh waktu, kita sudah overtime 5 menit.
Oke.
Ya.
Terima
Dr.
kasih.
Yanuar, saya ucapkan terima kasih banyak
Sama-sama.
penyampaiannya. Ya, mudah-mudahan kita bisa bertemu di Pontianak.
Insyaallah.
Jurusan kami Bapak Hasan. Untuk Pak Yanuar.
Seutang dengan Pak Hasan nih.
Ya. Ya. Pak Hasan ada di ruang Zoom. Oh, boleh Pak Hasan menyapa Bapak Dr. Yanuar? Pak Hasan?
Ya, Pak Yanuar. Assalamualaikum.
Ya. Waalaikumsalam. Waduh, muka pun hampir sama dah. Nggak kasih janggut ya?
Kurang jenggot ya. Ya, kita tunggu Pak Yanuar.
Insyaallah, ya, minta maaf ya, betul-betul hari itu ada di luar inilah, ya. Kita pun ada event kemarin cukup besar, ya, open day. Jadi harus 1 hari sebelumnya kalau mau ke Pontianak, ya. Insyaallah kita jumpa lagi. Saya kembalikan ke Pak Suarsono dengan Pak Jajang.
Baik, terima kasih Pak Hasan dan Bapak Dr. Yanuar. Kita kasih tepuk tangan yang sangat meriah sekali untuk narasumber terakhir kita. Kepada Pak Yanuar sekali lagi kami ucapkan terima kasih banyak. Selanjutnya saya serahkan kepada moderator sekaligus MC yang sangat luar biasa sekali. Beliau kita undang jauh-jauh dari Kabupaten Sukamara, salah satu kampus PSDKU dari Politeknik Negeri Pontianak, kepada Bapak Jajang Nur Alam. Disilahkan.
Thank you, Mr. Suarsono. And ladies and gentlemen, we have come to the end of this enlightening and informative international seminar. I hope you all have enjoyed and benefit from the presentation and discussion from our distinguished speaker. And I would like to thank them once again for their valuable contributions and for making this seminar a success. And I would also like to thank our advisory committee, Professor Dr. Ardi Marwan Amidi, and organizers, volunteers, and all of you for your participation and support. And please give a big round of applause to everyone who has made this possible. As we conclude this seminar, I would like to leave you with a quote by Albert Einstein. The important thing is not to stop questioning. Curiosity has its own reason for existing. Thank you. And I hope this seminar has sparked your curiosity and inspired you to learn more about the topics we have covered today. And I wish you all the best in your future endeavors and hope to see you again in our next seminar. Thank you and have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya, terima kasih kepada seluruh peserta, Bapak, Ibu. Mohon maaf sebelumnya mungkin ada sedikit ini. Bisalah kita mungkin foto bersama? Oh, sudah? Oh, sudah, saya belum. Kita belum, panitia mungkin. Ya, komite dengan peserta mungkin yang ingin foto bersama, silahkan ke depan. Ya, yang masih bertahan sampai akhir, terima kasih. Kami ucapkan sebanyak-banyaknya karena sudah bersedia mengikuti rangkaian acara dari awal sampai akhir. Terima kasih banyak. Terima kasih, Ibu. Oh, oke. Terima kasih juga yang sudah bergabung di online platform. Maaf, lupa tersampaikan. Saya mengucapkan terima kasih sebanyak-banyaknya kepada seluruh peserta yang sudah bergabung di Zoom meeting. Terima kasih banyak. Sampai ketemu di seminar berikut tahun depan. Atau mungkin bisa on cam semua yang ada di Zoom meeting. Oh, goib ya. Ya, baiklah, tidak apa-apa. Terima kasih sebelumnya. Oh, ada. Banyak kok ini. Banyak. Oke, mungkin bisa on cam, yang masih off cam. Masih misal on cam maksudnya, yang masih off cam. Ya. Satu, dua, tiga. Ya, terima kasih. Ada lagi? Udah, satu lagi. Oke, terima kasih. Dan untuk yang menyaksikan di platform YouTube, terima kasih banyak. Ya, sekian. Terima kasih.